May I cut in for a while now? It's been quiet, so if anyone can hear me.
Yeah, we can hear you.
Yeah, we hear you. What's your screen name? Introduce yourself to the class.
Tommy Grenvold. I'm down there somewhere.
Welcome, Tommy.
Hey, I was listening before and jumped in and talking about the flat Earth. So I'm actually making a video doing some research, and I am a glober. I'm going to say that first, so no one's going to have me, asking if I'm a global flat earther. But many times I have heard flat earthers asking for evidence for a globe Earth, and that's what I'm trying to figure out. If what I think is evidence for a globe Earth, or if maybe it's flat Earth evidence. So seeing there's so many people here, and hopefully someone can help me. What do you think?
Of course, that's what we're here for.
Cool.
So do you draw your conclusion based on your own evidence, or are you relying on other people's evidence, like the government?
First of all, I'm from Norway, so I don't care about your government. No, this is my own. All my own. My own observations. So I've been a part of this circus now for about 7 or 8 years. And I did this observation about 6 years ago. And I've been asking flat earthers for quite a while now to figure out how this would be better evidence for a flat Earth than a globe. I don't know if you heard of people like Gary Wybenga or Antonio Subras passed away, but yeah, he also. And Awake Souls. I asked those and a couple more, but I still have no answers for if my observation is a better evidence for a flat Earth or a globe Earth. And this is...
All right, well, yeah, I mean, yeah, I know of all those people that you mentioned, but yeah, if you want to present it, I think we're kind of between topics at the moment, so it seems like we could shift to this.
Yeah, it was quite for a while, so yeah. But I need some permission to stream here or something. You can't stream to this channel, it says.
Oh, okay, yeah, if you want to share your screen, I'll give you the role you need.
Yeah, thank you. Let's go this one. So, can you see my screen there? It's just a drawing in Paint. Simple drawing.
Yep. We see.
Yeah. So, I don't know if you're probably more with feet and stuff, so than meters, I guess. So, do you see my arrow also on my pointer?
Yeah.
Cool. I was standing down here in the left corner, about 71 feet above the sea level, and I was watching some wind turbines that are 1,066 feet above the sea level. And as far as I can see, there's still been no flat earthers who can make a prediction about how this would look in my photo. I have done this for 6, 7, 8 years, and I can predict that pretty easy on the globe, but I still need some predictions for the flat Earth.
So this isn't to scale, obviously, but this is an ortho. No. Oh, go ahead.
Yeah, no to scale, no. The height is to scale, but not the distance.
Okay, and this is an orthographic view?
Yeah.
So according to the Earth predicted curvature, are you also including atmospheric effects and whatnot in your observation?
Well, I have done this on all 4 seasons with the warm water, cold water, warm, cold air. So there really isn't that much difference.
Okay, do you know the difference? Do you know there would be a problem looking from orthographic versus looking directly in front of you?
Yeah, sure. Well, you guys said that, but this is just the data, the how it was situated in the real world. So using those data, it should be possible for making predictions on how this would look over a flat Earth. And that's what I've been waiting for 6-7 years.
Okay, why don't you walk us through the exact technical details if you have time, since this is your diagram?
Sure, just ask. What do you want to know? Again,
okay, well, apart from this, is this your only evidence, or do you have other corroborating evidence?
This is the one I've been struggling most to get an answer to about the flat Earth, if it fits or not.
Well, what's the question?
How this observation would appear over a flat Earth in my photo. I have done photos of this, but I would like to know the flat Earth prediction.
Yeah, why can't it happen? I'm trying to figure out what's the observation.
Again, this is me standing down the left corner here, 71 feet above the sea level. And the top of the wind turbines are 1,066 feet above the sea level. I haven't set a distance here because I would like to know how far away I'm going to go to that later. But just the prediction about how this would appear in my photo some distance away.
You can't. I mean, if the very second, right? You got that distance. You have no idea what the distance is.
Yeah, I do.
Right.
Yeah.
All right. So you know the distance, but there's a question mark. Why?
I could reveal it, but let's say it is when I'm standing 22 meters above sea level. My eye would be 22 meters on that hill over there. But that hill is 175 meters, and the top of the turbines are 325.
All right. So how do you know that image that you're looking at? That's whatever distance away that is some kind of top secret thing. Gotcha.
No.
Whatever it is.
I'm
how do you
getting
know
to
that image isn't shrinking, going up, or compressing? We don't even know the distance, dude.
I'm going to find. I didn't put it there. It's 68 kilometers or 42 or 43 miles.
Okay.
68 kilometers. But again, if the Earth, this is what I'm struggling about with the flat earthers. If I'm standing here, this is 22 meters or 71 feet. When I'm looking over the other side, this should be my eye level. I should be looking into that hill. And the top of that hill and the turbine should always be well above my eye level.
Huh?
Or, I mean, so you're thinking that you're under the thinking that. Sorry. So you're under the thinking that the objects. I know. I'm getting another call. Go ahead.
So you think you're supposed to see the hill above your eyesight, above the horizon, I guess? Like you're supposed to be looking up at it.
Yeah, that's perspective, isn't it? That everything converges down to eye level, but not below it, right?
Is the drawing what you saw, or what you think you should expect to see?
No, this is just the data. This is my height and the height of the turbine. And the distance is again 68 kilometers. That's 42 or 43 miles or something like that.
And you were looking down below your...
That was two of you again.
The picture's just to give us heights.
Yeah, this is just the data.
Yeah, he took the observation, right? And he went off of like absolute heights from whatever distance he measured, and then he turned around and put it on a flat baseline.
So this is about asking for if anyone could make a prediction of how this would appear in, as you say, perspective seen from my camera. Taking the distance
give me 2 moments. I'm going to jump on my computer.
Yeah.
I'm just confused. So you claim you made this observation and you seen it below your horizon, below eye level or something?
Probably much, yeah.
Can you share those observations with us, please?
That's the point. That's actually the thing I've been waiting for now for 6 or 7 years. I'm waiting for the flat Earth prediction. because I don't want to show everything first and then, oh no, that's not how it works. If anyone knows how the flat Earth is supposed to work, there should be very easy to make a prediction.
So you have the photo, you're saying, and then you're gonna show it to, or you're waiting for predictions. Then you have the photo, and you're trying to get someone to predict what the photo is. You're saying.
Yep.
So you want us to predict how we should see this scenario if it's on a flat Earth?
Yeah.
Well, you
exactly.
can't do it.
So Tommy,
You can't do it with
quick
flat
question.
or globe. Like this whole little experiment doesn't work because you can't even do it with the globe.
Yeah, I can do that in 10 seconds.
You're asking for like a white swan, and then you're gonna be like, "Look,
I can do my predictions in 10 seconds."
But Tommy, would you be willing to acknowledge that photograph that you take would change over the course of the day?
I have, as I said before, I've done this over all the different seasons, and there is.
And it looks exactly the same each time.
That's just a pixel or two different, yeah.
That's interesting because, I mean, we got plenty of guys on the globe science side that would say you should expect actually that the image should change. Now, you might be in a certain area that is not sort of subject to too much turbulence as far as the refraction index, so it might be a bit unique in that case.
Just south of Oslo, Norway. I can show everything later, but as I said before, I can do the predictions on the globe in a matter of seconds or a minute. So it's not impossible.
So you're 23 meters above sea level?
22, yeah. 21, 22 meters, yeah.
And you're
looking at the wind turbines, 325. That's just about 15 times my height.
But you said it's, how far away is it? 68 kilometers?
Yep.
Okay, let's think about
the distance.
I see Rick's guy is sharing his screen now, so I'm going to stop mine.
Well, you could keep your two so we can see.
No, could you leave yours up? I need that image.
Yeah, you can keep. We can do as multiple. You can leave yours up if you want.
Okay. Yeah. Cool. There. You see it now.
Okay, Tommy. Let's say put yourself in the position we're looking off into the distance.
Come on.
Oh wait, someone wanted to go? Go for it.
I think that was a hot mic. Red Ridge. Maybe.
Okay, so Tommy, Tommy, when you're looking off into the distance, right? How far is the horizon in your opinion?
To be really honest, the horizon in my image doesn't really have to do anything. The horizon is not a part of my observation.
Okay, wait. Can you see?
It's what's behind it.
Can you see the wind turbines looking in towards them from the vantage point?
Say again, please.
Okay, when you put yourself, where are you standing in your image, Tommy?
Down in the left corner.
Okay, perfect. So when you're in that left corner and you're looking outwards towards the wind turbine, can you see them with your naked eye?
No, they're too small. My camera is a Canon EOS 70 Mark II with a 400mm zoom. It's actually a 1.6 crop factors. It's a effective 640mm zoom.
Okay, perfect. Can you use any optical equipment to capture those turbines?
The camera, yeah.
So your eyes can't see it, but your camera can, right?
Those turbines are really skinny. Those are the towers are skinny as hell. So no, I can't see them with my bare eyes.
And can you remind me of the distance between you, the observer, and that wind turbine?
68 kilometers or something about 42, 43 miles.
Okay, perfect. Thank you.
So you're looking for a prediction based on your diagram for what the photo looks like that you've taken, and then you're going to either reveal the photo after somebody does a prediction.
Yes,
or
that's the plan.
Wait, Tommy. So it's 68 km away. We're 22 meters above sea level. How much Earth curve do you expect?
I haven't calculated that Earth curve. That doesn't matter.
You said it matches.
On a globe, that's the horizon is geometric, right?
Let's say just
you can do it in seconds.
111 kilometers is 1 degree. So this is about 2/3 or something of a degree, something between half and 2/3 of a degree.
To me, it's looking like this wouldn't be possible only if it is a flat Earth. This wouldn't be possible on the globe.
Yeah, sure. Just
because Earth curve.
Then I said, if you guys know how a flat Earth is supposed to work, this would be so easy to make a prediction of. That's what I'm asking for. That's what I've been asking
for
I'm 6 years now.
If you're not making any sense, but why would the Earth curve not matter if what you're seeing, if they think it's flat, right, and they went out and observed that, why would their observation be different from yours?
Again, the Earth curve is about 2/3, between half and 2/3 of a degree.
What he wants is absolute claims to why I see what I see. That's what he's asking for.
Oh, okay.
Well, if he's 22 meters above sea level, there's gonna be. If he's 68 kilometers away, there's got to be some Earth curve there. How much is that? Does anyone know? You said you didn't even calculate that.
I can show you.
But he did. He already said he did it within seconds. This is just like him getting you to commit.
The observation from where I was.
Argue against you based on his observation. He's trying to get you to commit to white swan, right? And then he's going to say, "Well, this is a black swan."
All right. I just want to know how much curve there's supposed to be.
From where I took the observation to the turbine to 1 degree here. So that's just about half or 2/3 of a degree.
You're saying degrees, but how much meters of Earth curve are you looking through?
You don't measure curvature in meters, you measure curvature in degrees. You don't look at the tachometer in your car to see how fast you're going.
I mean, there's one way you could calculate with degrees, and you could calculate the meters.
That's drop from
that there would be.
Yeah, it doesn't work like that. Degrees is measured curvature is measured in degrees.
So the whole Earth curve calculator, throw it out.
So it's optics.
If you are using 8 inches per mile squared, that's just drop from a tangent at sea level.
No, like add in standard refraction, add in everything. Like how much curve should be there?
Yeah, just about between half and 2/3 of a degree.
All right, but a degree could equate to a large amount of meters or a little amount of meters, depending on what you're talking about, what you're measuring.
Again, curvature is degrees, not meters.
I think he's referring to the height difference of the mountain or the hill.
Yeah, he's going to move away from the drop over distance. That's what he's doing right now. That's why he's saying degrees. He doesn't want to commit to drop over distance.
Because drop over distance, it doesn't matter in this. I'm 22 meters.
Why do you keep saying standing there at sea level, like
the only time you can use drop over distance sorry. The only time you can use drop over distance or 8 inches per mile square if you see eyes are half buried in the water. That's the only time.
But you're saying your claim is that it's curved, but the curve doesn't matter.
No, I'm saying that. Why doesn't that one work? Sorry, shit.
Saying drop over distance doesn't. You can't you can't change your baseline, right? That's what he's trying to allude to, but that's just false.
Again, that really doesn't have anything to do with my observation. Again, if the Earth is flat, it should be 0. So the prediction should be really easy to do. That's what I'm looking for.
Yeah, but if the Earth is curved, you wouldn't be able to make the observation at all.
Oh, show me the math.
That's what I'm asking. How much? Like, what? You didn't even measure for it.
I just took a whole lot of photos, and the turbines are there.
So then, welcome to flat Earth. I don't know what to tell you.
No, not before you make a prediction.
Huh?
Not before you make a prediction of how my observation would look on the flat Earth.
It would look how it looks in reality.
Okay, so when I'm 22 meters above the sea level and the turbines are 325, I will always look up to those turbines because perspective, right?
No, because when you're looking directly in front of you, the ground is ramping up to the horizon, and the above the horizon is ramping down, just like you would see a street.
But it would never cross my eye
level. What's going on here, though, right? It's a reverse of burden, right? It's like I need you to claim.
This is no burden.
I need you to claim what I'm going to see because I know it doesn't match the drop over distance.
This is no burden. This is just asking for
a
prediction.
Swan.
No burden. Just asking for a prediction. It's just be really easy.
And there's no like consensus, right? Because it's like you're asking for the answers of everything.
No,
it's like, well, I don't know.
Everything. It's a simple observation.
Right?
I heard
we didn't observe it though, so it's weird to ask for our prediction.
I heard you guys talking before all about the maps and all of other things, like you knew everything, and you don't know this basic thing. I find it funny.
Salty. So
those were ideas, bro. Nobody claimed to know them.
Sounded like it. But
yeah, if we believe the Earth is a globe, why are we throwing out the curve of it? That's the whole point. You're acting like you can't measure it.
I said it's between 1/2 and 2/3 of a degree. That's it.
Right, but how many meters does that equate to in front of your face? Is what I'm asking.
Well, if you make a prediction of the flat Earth, this would be 0, right?
No, in your prediction, what's the height difference of the mountain?
I don't have a height difference. I have a degree.
So you didn't predict a rate of curvature.
My prediction is based on a globe with a radius of 6,371 kilometers.
So you do have a rate of curve. So it does matter.
But the rate of curve isn't in meters, it's in degrees.
It's just weird the way you're coming off that none of it matters. It's weird.
If you don't like degrees, I don't care.
Right? As in like a percentage versus the actual drop over distance. He doesn't want to discuss that.
Doesn't have anything to do with this.
Absolutely does.
Okay, it's 0 because it's flat. Just show me the prediction. Should be easy.
No, I'm saying for the ball. If you have a ball, right?
Yeah.
There'll be a drop in height over distance.
If you have a ball, you measure the radius and use degrees.
Yeah, you can use degrees or you could just use a drop over distance.
Yeah, we don't do that.
Both are valid.
You're
saying one's valid and one's not. Why?
Drop
Why
over
would you
distance.
say that?
To be clear here, drop over distance is you flat earthers doing, not globers. We use degrees.
No, you use drop over distance.
No, because that would be from a tangent from 0. I'm not at 0. I'm at 21, 22 meters.
Yeah, you can just lift that baseline.
A ball with a radius of 3959, that has drop over distance. That's what you guys think you live on. So what the fuck are you talking about?
It has drop over distance, yeah, but we don't use it for observations because it's wrong.
Who cares what you use or don't use? It needs it to be it. It needs it to be a fucking sphere.
Yeah,
the fuck are you talking about?
We don't use it for observations because we don't have our eyes half buried in the water.
You don't have it. You don't have it.
Drop over distance is from 0. I'm not at 0. That's the point.
No, you could just elevate it and then do the math comparatively.
No, that's wrong.
Why?
That's wrong.
Why is that wrong?
How do you do that? Show me the math, please.
You just lift your line.
That doesn't...
lift your baseline. Subtract.
No, the math doesn't add out. That's been done before. I can't do it, but I said it doesn't work. You don't just lift the line.
It doesn't match. It doesn't match. I get it.
If you lift the line, it doesn't match. Yeah, because the math is wrong.
Oh, the math's wrong. So drop over distance. All those calculators are wrong?
No, because that's...
Obviously they're wrong because it's not a ball. My God, it's very simple.
Drop over distance. That doesn't show anything hidden because you're not at 0. If you want to show what's hidden, you have to use like Walter Bislin's Earth Curve Calculator. That's the one. You don't.
Right, but you would know. You would know how much of the object you should be able to see, right?
Not from drop over distance. That's from 0. That's wrong.
Yeah, if you put yourself on the ground, you hug your face to the ground.
Yeah,
and then you
then it
put
works.
something a mile away, right? Yeah, every and anything's gonna obstruct that.
If
but
you have
instead
your
of putting that
yeah.
point on the ground, just elevate it
No.
and use the same
Your
concept.
Earth curve calculator is in feet or meters, dude. It's what you put in. It's in meters or it's in metric or English. No, I've never seen it say Walter Bisland's fucking Earth curve calculator have degrees.
This is just a tactic from the globe. It's just like what they say. Nautical miles, right? 69 degrees per nautical mile. 1 degree per 69 nautical miles. It's just a tactic to avoid what we're discussing right now.
The thing I say is you can't use hidden height from 0 because I'm not at 0, and you can't just elevate the line because that's wrong. That's the wrong math.
So at what point does Earth curve actually obstruct our vision?
Depends on how high you are in the target.
All right, well,
we're at 23 meters. How about at 23
elevation
meters?
height's a fake. That's literally what he's saying. Elevation height's a fake because you can't use drop over distance.
From elevation, no. You can use it from 0, but I'm not at 0. From 0, it's okay. I don't deny that.
Yeah, so all altitude measurements are wrong. Or all elevation heights would be wrong. Oh, well, how'd you establish that? How'd you establish they weren't wrong?
I've been here now for soon to be half an hour, but still no one has presented a prediction about how this would work on a flat Earth.
Yeah, don't answer. I wouldn't either.
But because you can't answer, right?
You can't.
I do.
You haven't even shown us what it looks like.
So. Hold on. There's a lot of. Can I get 30 seconds? So there's a lot of angles this could be discussed because you're talking. Some of these guys are bringing up the globe curve and some of these things, which are all valid avenues to explore. I would say this. Can you see in the chat real quick? I just tagged you in something. The old oil rigs. Yeah.
Let's scroll down. Oh yeah, yeah. The
all right. So
Black Swan.
Yeah, let me just.
Black Swan, yeah.
Yeah. So somebody called it the Black Swan QE, but these are just pictures of oil rigs. It's not. I mean, it's associated with that phrase, but that was just QE that marketed it as that. These are just oil rigs, but. First of all, Ricksky is making a drawing on his screen share, so he may have something for you. And I'm not trying to detract from these other points these guys are bringing up because those are all points to bring up. And in terms of what it would look like on a globe and all that, it would be interesting if you showed the picture. But this is what I would say: it's very difficult to make a prediction, and this is why. So the one I posted there, and I'll post a second one, and this one says atmospheric magnification on it, but I'm not using that. The magnification right now, but that's the same location, same elevation, but different days. So the reason it's very difficult to make a prediction is because conditions change on a daily basis. So you see the picture on the left on a different day, parts of those oil rigs, the legs are cut off by the water optically. But on the right, you see the horizon far beyond the oil rigs. So in this one that you've brought up, depending on the conditions, how much of that hill or the wind turbine is going to be cut off optically. It's going to be difficult to predict in the same way that it would be difficult to predict on any model. If you go out on any random day, what's going to be cut off from those oil rigs optically. Now, the Earth is obviously not changing shape. The water's not changing shape. I don't think anyone's claiming that. And so, but this has to do with optics. So in the same way that different amounts of those oil rigs, the legs are cut off, in the same way in your picture, what I would expect if you were to share this picture, I would expect that part of that hill or part of that wind turbine is going to be optically cut off. Now, the reason for that is that my explanation for that is that on the ground level, you can see a certain amount of the ground, maybe 1 mile, 5 miles, 30 miles, certain amount of the water layer. And then you have the sky layer above that. And the horizon is made up of the meeting place of the ground and the sky. So depending on how far you can see of the ground layer, will denote where that cutoff is. It doesn't mean it's an actual physical cutoff from Earth curvature because it changes on a daily basis. But optically, this is the same thing as to why, the mast of a boat will cut off from the bottom up. Because in those oil rigs, for example, if one of those oil rigs is 8 miles away, on one day, if you have 15 miles of visibility of the ground layer, then the horizon is going to be far beyond the oil rigs and you'll see the whole the legs of them. On another day, where you only have, let's say, 6 miles of visibility, and if the oil rig's at 8 miles, since your visibility of the ground layer is only 6 miles, you're going to get the cutoff because everything past 6 miles, the rest of that optically is going to be cut off. So in your photo, in your side view of what you shared here, I would suspect that, especially when you're talking about, 60 kilometers, I think you said, 60, 70 kilometers, that's a very, very far distance. So one thing that's going to happen is the mountain or the hill here and the position of the wind turbine is going to be shrunken down considerably because you're so far away. So you're not going to look up to see it. You're going to be looking near eye level to see it because it's lowering and shrinking due to perspective. And then there's going to be a cutoff point of how far you can see on the ground layer. And I think that has to do with different conditions. On some days you can see more of the ground layer, on other days you can see less of it. So if you can only see, let's say, 30 miles of the ground layer, and your wind turbine's at 40 miles, well, then you're definitely going to have some amount of it optically obscured, optically cut off, because you can only see 30 miles of that ground layer and the object's at 40 miles. So all that information between the 30 and 40 that you would be able to see otherwise, but if the conditions were more clear, you're not going to be able to see. So if you were to show this picture, I would suspect that you would either have a portion of the hill or a portion of the wind turbine optically obscured because the ground layer is limited, and then the rest of it is the sky layer, everything above the ground. And if the ground layer is limited at 15 miles, 20 miles, that's the last bit of ground you can see. Therefore, optically, you're not going to see all the way down to the bottom of that hill. You may not even see the entire wind turbine. So that's, in a sense, part of how I would respond to this. It would be very difficult to get an exact prediction because conditions change on a day-to-day basis. The distance of the horizon changes on a day-to-day basis, which is why you get different amount of the object cut off on different days. From the bottom up, you get different amounts on different days. And I would expect that you can probably see a portion of the wind turbine, considering how far this is and how far the distance is. But that's how I would explain it. It has to do with the distance of the ground layer as that ramps up, and then the limit of that is going to be the limit, and then the rest is going to be the sky layer. And because this is so far and it's going to be shrunk away quite a bit, you're only going to see a portion of it over a planar surface.
Yeah, but if you're standing in front of let's say a light pole, a power pole, something, and you hold your hand up and you just cover the bottom of it, that doesn't make the top of the pole sink downwards. The top stays at the same place, right? So when you say that the turbines ramp down,
you get compression over distance. You don't always, but you can get compression. The image can shrink. The bottom can go up while the top goes down.
And that goes into the vanishing point, right?
Well, I don't know. Sometimes you get like a ghosty image that starts like teleporting around through objects. We had someone in here the other day, right? He was showing us a video of him on a snowmobile. Right, so he's out in the distance. I forget how far it was, right? But you can see his body, right? No, I'm saying the guy on the snowmobile, dude. I forget how far he was from the cameraman.
I didn't notice. Sorry.
Am I talking to myself?
Yeah, just I didn't hear you change topic, but yeah, keep going.
No, I was trying to give you an example of how things can do all. They can literally teleport. So he had this observation, right? He's out with a snowmobile. Guys, video recording him. He's going around. You can see in the background, it looks like the ice or the snow is like refracted. And you could see a complete borderless around, it looked like ice chunks just floating. Right, but then he'd drive behind him, and you could see it wasn't like an ice chunk floating. It just appeared to look like that. And as he was going through what seemed to be refracted, he was going behind the image, right? And then he'd teleport, it's like his body would blink in front of the image that was obstructing him. And then he'd go behind, and then once in a while, he'd just kind of reappear in front of the object that was occluding him. You get what I'm trying to say?
I have no idea. Sorry.
You don't understand that?
Nope.
Yeah, you'd have to maybe show it. Well,
to make it a little easier.
Yeah, I mean, sorry, Tommy, if I was a bit long-winded, but I'm just describing how the horizon forms. It has to do with the ground layer and the sky layer and where that forms. And so same with a boat. If you have a boat at 8 miles away and then the water, you can only see like the last little wave you can see is at 6 miles, but the boat's at 8 miles, then yeah, you're not going to be able to see all of the optics from that 6 to 8 mile. And since the boat is still shrinking and moving away due to perspective, you're going to get the mast is going to appear like it's going behind that 6 mile layer, because the 6 miles is where the horizon's forming. So when you're asking for a prediction, if there was no atmosphere, if we could see forever, if we had Superman eyeballs and there was nothing in the atmosphere, yeah, your orthographic drawing, your eye level would hit on a planar surface with level water where you're showing it right at the base of that mountain. Yeah. But because you have a tremendously long distance involved, you have the function of perspective, which everything is going to shrink. It's almost like a pyramid that you're looking at. Everything rises up, comes down. And when you get to these grand distances, that effect's going to be more dramatic. And then the fact that you can't see forever, meaning the horizon is going to form far before that mountain and that wind turbine, then you're going to have some amount of it be optically obscured over a planar surface. And this can be replicated as well. So, I mean, your photo, I would think that you probably see a portion of the wind turbine. And that's my prediction. So will you post it? I bet I'm right. Although, I mean, I'm right just as an estimation, because it would depend on the conditions considerably and all of that. But I would not expect you would see to the bottom of the mountain, considering this is what you said, 40, 50 miles and all the conditions
miles,
involved.
Yeah, and the hill is 175 meters and I'm at 21.
Yeah, so you may not be able to see any of it. You may not be able to see any of the hill. I mean, this is like the mast of the boat. You could say the hill is like the hull of the boat, and the wind turbine would be like the mast of the boat. So in the same way, sometimes we see part of the hull of the boat cut off. Sometimes you see part of the mast cut off. I would suspect you might not see any of the hill, and you might only see a part of the mast or the wind turbine in the analogy with this type of distance and the conditions, knowing that the horizon, I'm thinking is, unless you have incredibly clear conditions, the horizon is likely forming far, far before the 42 miles. So you're going to get obscuration optically.
Yeah, but then again, you said
Do you have the actual photos instead of the drawing?
May I? Yeah, it's coming, but may I talk to Geo? I'm just asking, you said about this optical things and the atmosphere and stuff. And as I said before, it's obscuring the bottom. But then again, if you're just obscuring the bottom, that wouldn't make the top moving downwards. The top would stay where it is, as if you're holding your hand before something. You don't move anything down, right?
No, that's different. Well, go ahead, Taylor. I mean, that's different if you're holding a hand, like an actual physical obstruction, because things are going to shrink, just like the street light. Yeah, the old street light. I mean, like this picture right here of just good old streetlights. If you're looking at the streetlights very close to you, of course you're angling your head up, but those ones at the bottom have shrunken down tiny. So that would happen with your wind turbine as well.
Yeah, but at what point would those streetlights pass the surface of the road?
If you have a very long distance to where the surface, it all depends on how far you can see of the ground layer. If you could see forever, then you would never get optical cut off from the bottom up on a planar surface. You never would. It would just approach zero and never. But the thing is, you do have a limit of how far you can see on the ground. So if your limit is 6 miles and your object's at 8 miles, you're not going to be able to see to the bottom of that 8 mile object. Your limit of the ground layer has expired, and then the rest is sky. And of that sky layer, if you have a wind turbine or a mast that's up in the sky, that's the part of it you're going to see. The rest of it's going to be obscured past the 6 miles.
Yeah, but then
I know, and I can talk.
Just a moment. Talking about perspective, like the top of the turbines would never cross my eye level. It would never pass the what do you call it again? Yeah, inside of the eye level.
Yeah, but you're under the assumption that we're seeing things where they actually are, right? You're saying just based on pure
geometry, yes.
Yeah, but we're not seeing like that though, right? Because things are shifting around in the distance.
Oh, that's news.
Well, that's another angle.
Is
well,
it?
I've said part of my piece. I know others want to get in. I mean, if this was like a 2-hour podcast with just you and I, we could keep going back and forth. But I know other people want to get in. So I've said my piece to a degree, and I can jump back in more. But I know Taylor wants to jump in too. But
see,
yeah,
Risk Sky is now about to
So can I
make
jump
something.
in now, please?
Yeah, let's let Taylor go.
I was just gonna say you definitely would see the whole thing shrinking. So what this is called, and actually the wind turbines, they don't stay in the same spot. If you were to go out there in different times of the day, different days, or times of the year, just whenever, diversify the times you take the pictures, you'd see them in different locations. They actually appear to move up and down. And so they're not always in that one same spot. And I implore you to try and do this. That would be something very interesting to do. But essentially what happens is the sun will heat up the surface of the earth. And that happens on, snow-capped mountains. It happens on the, the ocean surface, the ground, iced lakes, all kind of environments. But basically it's convection and sun heating up the earth. And then at that bottom, 5-10 feet, it is very profound, and that will cause whenever you have that type of mixing and that type of strong gradient, things are going to appear to be cut off over distance. And then that gradient, it doesn't just end there, it actually extends upward, but not as profound. Basically the whole thing is moving through a layer where the ground is warmer, causing lower density near the surface. The light's going to be bending up, making the whole object appear shorter. And I just mentioned at the ground, you're going to have a lot of mixing, giving it a cut off appearance. And these can be replicated indoors too with your own experiments.
Yeah, thing is though, Taylor, I did this all seasons, summer, winter, spring, and fall with the cold weather, warm water, cold water, warm weather, and the difference between those. Sorry, the difference between those are just mere few pixels, not anything big. It's just a few pixels in a 22 megapixel camera. So the difference is really not that big. It's small.
Do you have that? How many images do you have?
I have 4 here to compare with.
Can I ask a couple of questions?
That's what I'm here for.
He doesn't want to post them.
Soon.
Well, Taylor, when he started this, have you seen the image he posted? I'll post it again in the chat if you haven't seen it. But he showed this orthographic side view, and he's basically asking for predictions of what the photo. He hasn't really revealed the photo yet. He's trying to get a flat planar Earth prediction of what would be seen. So if you look in the chat, I'm reposting it now. That's basically what he posted, and it's he's 22 meters above the water, and then he's got this hill and the wind turbine. So he's asking basically, what is the prediction of a planar flat Earth prediction of what would be seen based on that?
I think it would appear to drop over distance.
And Risk Sky is doing a wonderful job. I'm watching his stream, and he's doing a great job.
Okay, thank you, Tommy. With your images, you said you have a total of 4 images. Do you also have the barometric, maybe the refractive index, humidity index?
These are over 4 different seasons, so just imagine anyone.
But you don't actually have any technical data, right? Humidity, you don't have any of that data in your observations?
Nope.
Okay.
Again, this is warm water, warm weather, cold water, warm weather, cold water, cold weather.
I agree with what Gio said. It's gonna be distorted, obviously, due to perspective.
Fun fact, it isn't.
So it's just normal.
Yeah.
So
it's
quick
not,
question.
When Gio showed the platforms, the oil rigs before, one of them are distorted like hell because of reflection. My photos are not like that.
Yeah, but there's other representations of those same types of distances where there's not the distortion. So it's not just as simple as, distortion, refraction, that means it's bending up around a ball. It's not that simple. There's many other shots where there's no distortion and you still get that optical cutoff point. There's a lot of factors involved. I mean, what I'm referring to is the distance of the ground layer you can see. Sorry,
Gio. Just as Risk Sky is going, just the pure geometry. Don't care about anything atmospheric. Just pure geometry.
You need to tell us the weather conditions. You need to tell us, was it windy? Was there a lot of mixing? What temperature was the water in the air?
Taylor, if all the photographs throughout the year are the same, it would seem that it's not really critical to the observation.
I promise you.
This is
so there's no distortion. We just see the whole hill and we see the wind turbines. It's not shrunken.
Taylor,
the thing about the temperatures, though, right? You can have what temperature? What's the difference in temperature between summer and winter in Norway?
Exactly. This is in Norway. We have cold winters.
So just to go at it this quickly, right? So because this diagram that I pinched off your screenshot there, it's not to scale, right?
No, of course not.
So this occlusion zone that I'm including here, this is my understanding of what happens if you take say this mountain, right? You're looking at the light coming off of it, in order to make it to your eye, is basically going horizontal, but because it's within the dense medium, right? It's the densest part of the medium down on the ground. This light is bending downwards, right?
Okay.
Cool. So as a consequence, when you go to take any object at the distance, you can say that as it moves away from you or you move away from it, the occlusion zone from the bottom up occurs. So you can see how, so if I take this idea, this is my occlusion zone, and I can squeeze, and it depends on conditions, how this behaves, but you're saying it's pretty standard. My issue is that when I try to map this onto your diagram here, I can't do it because it's not to scale. But okay. Basically, what you would expect to see, right? Like, see how you see the base of the hill that the windmill is sitting on, and then we tighten this up here. It'll include the whole hill, and you'll just see the windmill chuffing over the top. Cool. I don't know what your distance is, though.
68 kilometers.
Sorry, what was it? 68 kilometers?
Yeah.
Okay, cool. So if I move this.
By the way, it's not necessarily that surprising if it's consistent. There are some areas that are actually quite consistent, the conditions. So, especially when you're looking above the water, like not right on the water, but above it, more than like the oil rig.
Yeah, especially with humidity, no?
The sun heats up the earth consistently every day. Like no matter what the temperature is, the ground is still being heated up throughout the day at a consistent rate where it's much warmer than the air above it.
I also thought of that, Taylor, because I was there at sunrise, midday, and evening, and sunset.
Mm-hmm. We'll post them.
Yeah, it's soon to be. I see Risk is clear.
You have the night. There. Can you see it at night, like any nighttime photos? That's when the temperature gradients even out, less refraction.
Sunrise. I can't do it at night.
What's this?
It's dark. That's a lighthouse.
That was a lighthouse, wasn't it? So that would be within the image. I can't quite tell you how much you're necessarily going to see of this hill or that, although I suspect, what is it? Most observers, you can see if you're 22 meters above the ground, it does mean you can usually see quite far. And so I think you should see all of this. I just can't work out right now what exactly would be happening over here. I suspect... Yeah, would you see the base of the mountain or not? I'm just trying to work out how this refraction
shed should be handled. I'm really impressed about this, Rick. I really appreciate this. This is awesome. Thank you.
No worries, man. I actually have to duck, but thanks for introducing this idea. It's kind of interesting. I've been playing around with this diagram, and I wanted to see how it would go, because I've got all these sort of other things, but I'm not able to model too quickly at the moment. Getting a bit hard to sort of handle the information and how to input it, but I'll leave it at that.
That's not actually half bad.
But even on the globe Earth, like, you can't predict it on the globe Earth either, because they have like what they claim is the curve, but everything doesn't just cut off at the curve consistently. You have different days you can see further, different days you can't see as far. So that's why on the globe Earth, this side of the discussion, they always bring up you have these refracted horizons, they call it, so, and they have different theories of how the horizon is refracted differently on different days. So, I mean, if I showed you a picture and said, hey, how would you predict this on the globe? You wouldn't really be able to do it either. And I'm sure I could stump you if you were just to say, well, here's what the curve should be, so it should cut off right there. We'd be able to show pictures all day and say, nope, it doesn't cut off there. So it's pretty impossible to really make a prediction unless you perhaps could know all the conditions and all of the effects, all the way through, because you get, there's variation, but it can't be predicted on a globe.
Here's the thing,
either.
Gio. Try me, please. Just go out, make an observation, and give me one of two pieces of data. Either your height, the length, the distance, and the target height, or the coordinates of where you are and the coordinates of the target. That's all I need, and I can predict it in minutes.
And what happens when you're wrong? What happens when it doesn't match the observation?
I have done this now for 7 years, and I haven't been wrong yet. Sorry.
Black Swan's fake. Cool.
No, Black Swan is full of distortions.
Mount Canada is repeatable.
Yeah, I had done that. Would you like to see it?
Yeah.
Yeah, let's just show my observation first. First. So, back to my screen. Risk Sky. Thank you. I appreciate that. So, back to my screen if you see it.
Yeah, but you can't really predict Canada. You can only predict it based off the picture. You see how it looks and then add in refraction to match it.
I have done it. So, if you see my screen again.
Yeah, we can see it.
Yeah. Just to show, this was in winter, cold weather, cold water. And this is in the called spring, isn't it, after winter? Fall, spring, yeah. I always cross those two. In March or something. A bit warmer. This is in the summer, people are bathing and stuff. Hot weather and hot, yeah. And I get shabby, but yeah. So, to make sure that my camera is level, I set up this water tube here. So I have something to align my camera over. Even though I also have a digital level on my camera and a bubble level on my tripod. So I'm sure that my camera is dead straight. So these in the front here are the island of that lighthouse. So that's not that hill. The hill, you can see the water behind here. So that's not that hill. But from my 22 meters to the top of the turbines, those are below my eye level. And according to perspective, that shouldn't happen. Also, that lighthouse, as you see, I had in my drawing there, I see just about the bottom of that white part here. That's 47 meters. So my line of sight has to do something really crazy for this
Okay,
match.
keep it here. Keep it here. So you're saying just on geometry, it shouldn't happen? Is that what I'm understanding? Yeah. Okay, so why are you not understanding the magnification or the effects of the atmosphere to explain this? Sure, we can understand the geometry. It doesn't apply. It doesn't match geometry, but life's not geometry, right? We're not living in a geometry world, right? What about the atmosphere? Wouldn't that explain anything for you?
If atmosphere just magnifies stuff, it will be bigger, not pull it down.
But wouldn't there be other effects? If we could magnify, wouldn't we have other effects, maybe the opposite effect?
As what?
I'll try to find you. One moment. You guys can continue. Thank you.
Just let me address that magnification. I also tested that one, of course. Just going to find my channel here and videos. This is a few years ago, so I just scroll a bit back here. I'm going to find it soon. After that one, I guess. There.
So it's about what I said. You can see half of the wind turbine, the leg of it, and you can't see the hill. Although I didn't know there was a lighthouse with land in between it, so that obviously would be obscuring.
Yeah, the lighthouse was in that drawing, but yeah.
I didn't know there was land, though. I didn't know there was an island between it. I thought it was just a straight shot of water.
But you can see the water behind it again in a few places. But again, you did an awesome job. I tested this.
Okay, what about the atmospheric condition called demagnification?
Wow. I tested atmospheric lensing here, and I shot. This is about 10 kilometers away through some on a clear day, on a day with fog. And those line up pretty damn well. There's no magnification here.
No, demagnification.
Wait for
it.
Right,
there's magnification, and then there's demagnification. Are you aware of that?
I drove a further bit apart and did the same thing through fog. And there's no difference, like 10, 12 kilometers away. So there's no magnification.
Hold on. Do you agree that there's atmospheric demagnification, yes or no?
What is that?
Okay, it's a rare effect. Let me get it for you.
Yeah. So when I was out there
hold on. Are you saying so you're saying this effect is not true? Is that what I want to hear you say?
I never heard of it.
Okay, so just because you haven't heard of it, does that make it true, yes or no?
Say again, please.
Okay, so just because you are unaware of it, does that make it false?
If you can't describe it, that would help a lot.
Hold on. Just because we can't describe it, I'm not describing it to you right now. Does that make it false? If it's documented, observed, are you out now saying that's false?
Show me, please.
Okay, one moment.
Again, you said it was rare, and I was there during 4 seasons, so it should be at least one of them, shouldn't it?
Yeah, finish your presentation because I have some things I would like to share.
Yeah, again, this is my observation, and I don't see why those turbines should be below my eye level, according to anything. And again, just to show, you asked for the 4 different times there. Here are all 4 seasons on top of each other. And if I close one and one layer, the turbines are in the exact same place. So there are really not that much of a difference.
Okay.
Those are all
Finish
4
your,
on top of each other. That's bright, yeah. Oh, sorry, not all of them.
You're saying that the turbine should be at like halfway up the lighthouse. Is that what you're saying?
I say they should be above my eye level. I'm looking up to them, but this is looking down. My eye level is that top white line there.
Okay, gotcha.
So just to show, as you said on the perspective thing, I have done this in SketchUp as a prediction. And on the flat Earth, whoop, that's too far.
Okay, so are you from Okay, I'm gonna post the information about the. Oh no, Taylor, sorry. If you wanted to continue.
So on a flat Earth. Oh, you're roboting. On a flat Earth, I should be.
Go ahead, Eden.
This is my eye level on flat Earth at 22 meters. That is well below that white line on the lighthouse, and the turbines should be above my eye level. On the globe without refraction, sorry, this is a bit hard to steer because the zoom. On the globe without refraction, I should be seeing this, and that's damn near close to what I saw. If we add a little bit of refraction, sorry again, this is, when I zoom in 2000 millimeters, it's really hard to adjust, but bear with me. There.
I think we're all, are you trying to show a different screen? We're seeing the one with the orange sky.
Oh, you don't see a SketchUp model?
No. You might have to change the, if it's on a different window.
Okay, yeah, I'm going to change. Sorry for that. And I'm going to place my guy here and I'm going to stop sharing and share again.
Yeah, you can just swap
I think I missed some morning and evening one. If you still had the morning and afternoon one, do you still have those? Okay, I might have missed them.
That was the pictures. Let's see.
We're going to break it down.
Yeah. So this one is at sunrise.
Yeah, we see it now.
Where?
Yeah.
I just see a sketch.
Oh. Now you see SketchUp, or what do you see? What do you see now?
Yeah, I see your sketch. I don't see it.
Let me just.
I see stream pause.
I'm going to close the stream and start streaming again.
Computer model.
How about now?
Yeah, now we see the photos. Yeah.
Yeah. So that one is at sunrise, and one of the other here is that one I think is at evening or something.
Go back to sunrise.
That one.
Where is the wait? Oh, this one's at sunrise. Okay.
Yeah,
gotcha.
The sun is right there.
Okay, I'm just confirming. You keep your camera in the same exact spot, right? The same elevation, same distance.
Yeah.
Okay, good. That's perfect. Good job.
I'm standing. Let's see. No, not that one. Here. This is on top of.
Where is the eye level line?
This is
for the sunrise
restaurant at the end. Actually, the end of the world. That's the name of it. Verdens Ende, the end of the world. So I'm standing on the top of that terrace thing here.
That's a lie.
Do you have the eye level? Do you have the eye level line for the morning and sunset one?
It's actually exactly the same. It's this one.
Can you wait? What?
Do you see the water tubes?
You?
I guess so. Is that morning?
That's the sunrise, yeah.
Is this looking the other way?
No, everything is the same way. You see the lighthouse and the turbines.
I know.
Okay, so
and
the
some
lighthouse.
of them are like more zoomed in than others.
Say it again, please.
So those are the wind turbines. Okay, go ahead, Taylor. You're a little delayed, but I was just that's the same. That's the
yeah.
That's
it seems like some of them are more zoomed in than others, and some have the eye level line and some don't.
Yeah, this is zoomed out. This is 24 millimeters or something. But you can still see the turbines behind here, but very, very badly, because I had to zoom in on the water level.
Very badly?
And you can't do both at the same time at that distance. That's impossible. So I just...
can you zoom in on that or something?
Like just doing that, maybe?
Zoom in? Was this afternoon?
This is sunrise.
This is sunrise. Okay,
yeah, the sun is right there.
Zoom in on the sunset one again.
It's like
the sun.
Evening.
Sunset, yeah.
And this is half a year difference.
So can you see all of the mountain, or is that just part of it?
Now you see the hill behind here. Actually.
Now zoom in again,
That's the hill.
That's all of the hill, and then shrink.
But again, that's behind this island, so you can see it down here. Yeah.
Well, that doesn't work.
Yeah, but isn't this what we predicted or Geo predicted? It's gonna shrink due to perspective.
Yeah, but
you're gonna see part of the mountain. You're gonna see the wind turbines.
This is the thing with everything that top white line there is my eye level, and those turbines, which are 15 times higher than me, are below my eye level.
Yep.
So is your argument about eye level, because that gets kind of tricky when you're trying to aim a camera and you've got, I know you have the water tube there, you got different zoom levels, because the one you just showed before, that looks like it was clearer conditions. You could see the hill,
right?
You could see
the Geo is talking, please.
I know, this guy's over talking.
Hey, Geo was talking.
Yeah, what I was saying is that go back 2 pictures where you could see the hill that the wind turbines are on before. Because that one, that one.
This one, yeah.
Yeah, so you can see the hill, you can see more water and the hill that the turbines are on. So that is more clear conditions, because those should be cut. There should be on the globe Earth. It's like 200 meters of curve. So zoom in right there. You have a planar Earth observation right there. Zoom in. So you can see the hill that they're on. That should be 200 meters should be cut off if there's Earth curve. So you have a see too far right there.
The problem is, though, that, as I said before, all of these four are the same thing. There is no difference for where the turbines are in the photo. And where did I put that?
Yeah, but that's what I'm asking. Are you trying to do an argument of eye level and trying to make some things there? Or are you talking about how much of it is cut off from the bottom? Because in those two photos, one of them there. You have, which looks like, that one looks like it is about 200 meters cut off. You can't see the hill, although this is very different conditions. It looks like this is further down. Well, because you can't see the water in between. So you have different, just like the oil rigs where the legs are cut off on one and then they're not cut off on the other. You have that effect here. Here you have the hill is cut off, whereas the other ones you see the hill, and it's supposed to be 200 meters should be cut off is what the basic globe curve without refraction should be, with a 22 meter height and 68 kilometers. It's about 200 meters, right? Is what the globe curve would be.
The thing is. This is, again, below my eye level. Those turbines are 15 times higher than me. They should be up here somewhere.
Right. Well, you're saying they go down, too. They're dropping, but...
That's the exact point, yeah.
Right, well, that is...
Do you remember when I was...
Yeah,
sorry. Do you remember when I was diagramming out and saying that light at a distance will bend down?
Is that Rick Sky?
When I was drawing on that SketchUp, when I was drawing that SketchUp model, I was saying the light bends down at the distance, and that's what happens. So those windmills, like their image will be turned down at a distance because as light traverses through, it's bending down in that denser medium.
Yeah, the water. See how the water disappearing kind of before the lighthouse.
Then
effectively.
Let me answer this guy. Then again, if everything was bending down, this would be squished. That the thing between here would be squished together. This wouldn't be without distortions. This would be squished from bottom to top and top to bottom. It would be squeezed.
Can consistently, if it's a standard gradient, it will just appear to be sunken. I already explained it earlier. And by the way, the light would be bending upward to make things appear shorter.
But then again, everything in between there would be squeezed together. You can't down anything without squeezing it.
You're missing water.
No, you can literally repeat it you can repeat it on a small scale. All you need to do is introduce temperature gradient near surface, getting cooler as you go up in elevation. You'll see it consistently. Everything drop, and then the bottom will be cut off due to the profound gradients. And this can be replicated.
Do you see my SketchUp model here now?
No.
Damn it.
Same picture.
I don't know what the screen sharing is doing, but...
Look at the windmill on the far right.
Discord doesn't like me. How about now?
Yeah.
Yeah, so that's my SketchUp model. And just pure geometry. This blue line here is my eye level. And according to, not according, but in my photo, my eye level is above that white piece there. And if we move on to the globe model right here, we have...
Shit, you modeled this out well, working around. Okay, cool.
Here.
Yeah. Well done, Tommy.
Thank you. This is the globe model without any refraction. That looks like a whole lot better because that turbine is just about where it should be. If we go to the globe model with some refraction, as I said before, this is hard to be to stare. You didn't see that, but down here, with a tiny bit of refraction, now it fits just about perfect. We see some of the hill down here, the green part, and that turbine.
Wait.
And also,
are you saying that some refraction would make it look taller? Is that what you're saying?
No. Not taller. Just refraction makes things higher in the distance. So refraction actually doesn't help you. But this
you're wrong. Like, what conditions are you assuming for this? Light doesn't always.
This here is standard refraction.
Yeah, standard refraction does not apply on the surface. You should read some new papers on it.
Wow.
I'll send you some.
Yeah. So let's go back without refraction right here.
So what about the opposite? What about where refraction makes things appear to drop over distance? That's not an option?
Here. This is without refraction. Still fits.
That's a great point, Taylor.
This is a whole lot.
Okay,
This is a whole lot better fit than the flat Earth, isn't it?
Just blow right past my point.
Yeah.
Tommy, did you hear the point that Taylor raised?
Yeah,
it's
refraction.
Okay. I'll wait for him to finish. I'll wait for him to finish. I'll send him some stuff out there. Okay, go ahead.
You're a bit low, but yeah, I heard it. Refraction makes things bend towards the denser medium, so everything in distance should be looking higher. If you have something looking lower, you have very rare. What do you call it?
What affects density? What all affects the density? Do you know in the atmosphere?
Density. That's pressure. But refraction isn't density. Refraction is temperature.
And pressure.
The refraction is mostly temperature.
You're right. You're actually right. And so, do you know what higher temperature does? What does it do to density?
It's not the temperature itself. It's the change in temperature over height.
Right. Okay. So higher temperatures relative to another will do what to density?
I don't know where you're going, but as I said before, you see in a picture.
Do higher temperatures lower or least density? Do you know?
I done this all 4 seasons with different temperatures and
all
this. There really isn't much that change in
my question.
Please, it doesn't matter.
You'll understand.
I tested this.
Matter.
No,
it doesn't. Look.
Please, I tested this. It's in my photos.
All 4 pictures,
different densities, different temperatures, and it's just the same all over.
How do you know the density was different? Sir, let me know when I can ask you a question. What does higher temperatures do to density?
Why doesn't this make any difference to my observations?
Dude, just answer the question. Do you know what higher temperatures relative to another would do to the density? How would that affect the density?
Yeah, if you have high temperature, you have lower density.
Yes. Do you know what we have near the ground? Temperatures compared to the upper atmosphere. What are the temperatures near the ground?
Higher.
Yeah, so that would mean lower density.
So when I did this in summer and winter and fall and spring and there's no difference?
Yeah.
Yeah, so why is there no difference?
Every day of the year. Okay, so the sun does solar radiation will heat up the earth everywhere in all seasons, causing convection.
Yeah,
this will make
sunrise.
a profound temperature gradient near the ground, and as you just mentioned, higher temperatures lower the density.
I did this at sunrise. There's no heating there, there's sunrise.
The ground is almost always warmer than the air above it, and then furthermore, if the sun is coming up, I mean, that's going to make it even worse. I mean, midnight would be better, but yeah.
You think I would see those at midnight, do you? 68 kilometers away?
The ground is still warmer. The ground is normally warmer than the air above it. You just have to measure, and plus it holds heat because the humidity is much higher too. Humidity also lowering density, but that's it. The effects aren't as profound on our spectrum, but humidity will lower density. We have higher humidity on the ground. Higher temp lowers density. We have higher temp on the ground.
Yeah.
And this is all year round.
It would change because, again, this is Norway and the winters are cold. The water was cold and the sea was...
But as you just said, it's relative to something else. So the ground's still going to be hotter relative to the air above it. That's all that matters.
No.
Yeah.
Not in spring, because then the weather is cold in fall, autumn.
Because what? You just mentioned every single season. What are you saying?
In the fall and autumn in Norway, when the water is warm and the weather is cold.
That would make it even worse.
Still doesn't affect my observation. It's just the same.
No, the water being warmer and the air being colder is what would make things appear to drop over distance. Even more so.
Nothing changes in my observation.
It doesn't matter. If you're doing it during the daytime when the sun's up, you're going to have...
Do you see my screen now with the sunrise, where the sun is sticking over?
It always gets colder with elevation.
And just stop again, and this Discord is there. Yeah. So again, it doesn't matter your temperature stuff because it doesn't make any difference to any of my photos.
You just said earlier it's the main thing with refraction is the temperature. So what do you mean it doesn't matter now?
It matters to refraction, yeah. Temperature matters, yeah. But it doesn't make any difference to my observation.
Why? Why do you think that?
Reasons unknown, I guess. I have 4 photos during 4 different seasons and during sunrise and evening and midday, and there's no difference to my observations. None of what you're saying is doing the difference to my observations.
Listen, which season does the atmosphere not get colder with elevation? Which season of the year?
None.
It's every season. The atmosphere gets cooler as you rise in elevation.
Yeah. But anyway, I was 21 meters.
You get what I'm saying, right?
I was 21 meters above the sea level, right? And from where I'm
standing.
Matter. So why doesn't it make a difference to my observations?
Dude, I'm telling you, every season it gets colder with elevation. Warmer air brings lower density. And so you need to figure out, which type of refraction you're expecting to see, because near the surface, that standard refraction model where you say, oh, it's going to make things look taller, is totally wrong and bunk, and I can give you multiple papers on it. Peer review papers.
Light bends towards the denser medium. The denser medium the denser medium is at the bottom.
But we just went through this. What is in play with density? You said temperature. I said, what does warmer temperature do to density? You said lowers density. I said, which way does the temperature gradient go? Oh, well, guess what? You got the warmer air near the ground. Remember? Warmer air lowers density.
Refraction makes distant objects appear taller.
How do you know that?
That's just how it works. We know how refraction works.
Oh, yeah, but you're going off the standard refraction model where they assume one set temperature in the troposphere. No, they're not taking into account.
I'm not on the troposphere. I'm not at the ground level.
You're in the bottom layer of the troposphere. That's what you are in right now. So anyway, there's multiple papers that go over this issue. You cannot assume the standard refraction where they're not even taking temperature into account, the temperature gradient, and you can't apply that near the surface because it is what it is. Look, what I recommend you do, which is what I did, is go get a nice thermometer and measure some of these temperature gradients so you can see which way the light's bending. Because I can guarantee you almost every time you'll find exactly what I did. Even at night, I find the light bending upwards. I did a laser test. The light was bending upwards even at night.
Again, then there would be some difference to my observations because I was in a hot
weather. No, there wouldn't.
Of course it would be.
Every single season, no matter if it's hot or cold outside, the atmosphere is still getting colder as you go up in elevation. That means the denser region, based on the refraction standard refraction equations to get density, that means the denser region would be above the ground, especially near the surface where you got an extremely profound temperature gradient. I can write it all out for you if you need me to.
But again, that would make a whole lot of difference to my observations because I have 4 different.
It would make everything.
I have 4 different temperatures and what do you call it? Sorry, I'm just looking for the English words here.
Seasons.
What do you say?
Seasons.
Yeah, there's 4 different seasons. Yeah, but
doesn't matter. I just told you why. I just refuted that. Now you're saying it again. Is it? Are you on a repeat?
No, I'm just looking for the English words. Sorry, I'm from Norway, so
no,
English
it's okay.
is not.
I would happily go through it with you. I would love to, but right now, I don't know. Maybe in a little bit.
Yeah, I'm probably come to it. Yeah, I'm just looking for the English words. Sorry about that. But again,
it's okay.
Lapse rate. That's what it is. Lapse rate. The lapse rate from 0 to 10 meters, that's the worst thing, and I'm at 21, so it really isn't that much difference. Again, the gradient itself would be very different from the seasons, so the gradient would be making a whole lot different from my observation from photo to photo, a whole lot.
No, all throughout the seasons, every single day, the sun, even in the nighttime, the earth is much warmer as you're lower in elevation. Have you ever been up in a hot air balloon or an airplane or climbed a mountain, it gets much, much colder as the mountain.
Yeah, but again, as I said, the lapse rate itself,
you know what I mean?
The lapse rate itself would be so different that it would make a difference to my photos. From the cold winter to the warm summer, with the cold water and warm water, the lapse rate would be a very different thing. And again, I was there sunrise, and as you see, if the correct photo is up on my stream now, I do have the sun just poking over the horizon, and nothing has been heated up.
Tommy, I really appreciate your patience, and thank you as well, Taylor. Can you just inform, maybe there's people in the audience, what lapse rate is for us all?
The difference in temperature from sea level and up towards 1, 2, 3, 10 meters. The difference in temperature.
Okay, thank you.
Every season, you're going to get it colder in higher elevations. You can't get around it, bro. That's just what it is.
Oh, well. Again, not that one.
I mean, we've made things disappear just looking into a cold, like from a hot into a cold medium. So I don't know, like a light, just line of sight, didn't move anything, had line of sight on a light. You can make a whole light disappear over the distance of a warehouse. So it wasn't even that far.
Yeah, I have seen those, and that floor isn't flat.
Miles and miles.
I have seen those warehouse pictures. That those floors aren't flat.
It doesn't matter if the floor was flat. Yo, my man, it doesn't matter if the floor was flat. We didn't move anything. We just had a line of sight on a light.
Yeah.
The floor could have been the Rocky Mountains.
I'm
serious. No, we didn't move. He didn't move anything. He didn't move anything, and he made the light disappear. That's what I'm saying. Like, it doesn't matter what the floor was doing.
There's another problem with my observation, though. If you can see if the correct photo is up on my stream now, the lighthouse and the sun just poking over the mountains there. Is that what you see?
The mainstream model says the sunset phenomena is due to refraction. They say that it's being oblongated, and it's actually technically behind the curve, but the only reason you're still seeing it is because it's being refracted up. So the sun going through all the different density layers in the atmosphere, you're gonna have like you would expect to see these things.
I was just asking if the correct photo is on my stream now. The sun poking over the horizon.
Hang on, sir. You said it's a problem with your photo. I think that might have been a Freudian slip.
According to the flat Earth, it is, yeah. Again, to figure out if that correct photo is on my screen now, the sun just poking over the horizon. Is that what you see now?
That's not the size of the sun, though. It's being magnified, right?
I'm just asking if that's the correct thing that you see.
I think so.
Yeah, cool. That's what I'm asking for. So that's just the sun poking over and me following the sun upwards to where it's... I don't have a solar filter, so this is just an 8,000th of a second shutter speed. But the thing is, though, there is the entire sun. Going back here to...
That's obviously not the right size, though, right?
What do you mean right size?
That's not the actual apparent size of the sun, right?
This is zoomed in by 600.
That's not the angular size of the sun, right?
This is my camera zoomed in.
The actual apparent size of the sun is kind of a strange phraseology.
My apologies. Yeah, that's not the angular size of the sun, is it? That's just an apparent size?
This is zoomed in by 640 millimeters. So it's not that's not normal eyesight 50 millimeters. This is 640 zoomed in.
Yeah, but he's saying the sun size is changing. Like there's
no, I'm not after the size of it.
Going on.
I'm not after the size of it. The thing is, though, here, that sun is below my eye level.
Apparently.
No, it is. As I showed here, from that photo. If you see, now it changed. The Discord is messing with me, so I don't know if it changed or not. Do you see the water tubes in here now? I'm not sure if Discord changes my photo or not. It's messing me up. Anyone?
Yeah, I'm just taking a screenshot so you can see what we see. I'll post it in the live stream for you.
Oh, yeah. Oh, it didn't change. I don't know why. I don't know why Discord is doing it. Yeah, that's the one I had before. Now I changed now, but Discord doesn't want to have it. You can see the sun just popping over the horizon there. But that is below my eye level. So the sun is below my eye level. Again, I have to, I should quit, but
So the sun being below your eye level, is there one or two explanations, possible explanations?
One explanation is the globe. I don't know what the other one is.
I think, isn't it the mirage with the demagnificate? Let me see if I can find what it would be. I'll post it in the text chat.
As things, if you're in a hallway and something's going down the hallway over your head, as it keeps going, it's going to appear to merge with your eye level. And so it's going to drop. And then as it's dropping, now you're looking at it through this certain angle. Now you're going to be looking through a lot of different gradients of atmosphere, which, like I said earlier, would make objects appear to be cut off. That's just predictable and repeatable.
And how high up is the sun?
It doesn't matter.
Of course it does.
It doesn't.
If the sun is 3,000 miles up, the angle toward that sun should be 26 degrees.
Nobody said it was 3,000. If you're going to posit that your things are a globe, then you need to tell me the, atmospheric conditions and temperature gradient. I'm not going to ask you that, though. I doubt you took them.
I need to stop my sharing and start again because this stupid Discord isn't cooperating. So I have started stream again. If you see my SketchUp model here. So down here, seen from where I am in just north of Oslo, Norway, there. For where the sun is at sunrise, that is at 26 degree up here. The sun is following that right line. So this hallway of yours with a 3,000 kilometer high ceiling, it doesn't make the sun go down here. That is because all hallways need to be pretty as big for this to work. These are the hallways.
Well, that's not how it works, I guess. Speeds up and slows down. Yeah, but it's a great model.
Yeah, it has to speed up because 1 hour around here is half 1 hour around there. So yeah, the sun needs to speed up. No one has ever seen it.
Speed up and slow down?
Yeah. If you're living at the equator, you should see the sun going twice as fast in December as in June.
Do you give the code to your simulation? Why do you assume that? I do want to know about the December gene, but do you give out the code to that simulation?
Code to what? I don't know what you're talking about.
Like the simulation that you're using? Like, do you let other people have access to it?
Oh, the SketchUp model. It's just it's the SketchUp model.
Yeah.
Yeah.
Do you ever share it?
Should I? Is someone using SketchUp?
I want to use it.
Yeah, it costs you like $300 a month, I guess.
Really?
Yeah.
I'd still try it, maybe.
I have the free version from 2017, but you don't get that anymore.
Can you get it with universities?
I don't know.
Yeah, there's usually an educational version. You can apply for it if you've got a university email.
Yeah, can you send me your thing or whatever?
I wouldn't be inclined to send out your model, sir, but it's up to you.
Yeah, that's...
don't feel pressured to.
That's kind of not my baby, but it's like my own photos. I just don't share that, yeah. But
how many hours you reckon it took you to model all that?
What do you say now? Sorry.
So just quick question. How many hours do you reckon it took you to model that?
Not hours. I've used SketchUp for many years, so this is just... That one is, let's say, half an hour or something.
Oh, what? That with the 3 different variations, you did that in half an hour?
Oh, that one. I didn't time it, but yeah, around that. As I said,
maybe I try to make that as I'm going to school every day.
My biggest SketchUp model is just about half a gig with a house with a lot of stuff in and around. So I have used SketchUp for a while.
Yeah, I've used it for a fair while. I've just come back to it actually. My files can't get that big though. I haven't got a computer to handle it.
Yeah, I mean, maybe if I wasn't in school and I could just stay home and play with SketchUp all day, I'd totally make one. But yeah, I mean, you don't have to send it to me. I just thought it'd be courteous. Yeah. I didn't know if you shared it or not, But I get it if
But as I asked you before, with this sun below my eye level, how is that possible?
I want to see, I want to play around with it and see what you're talking about.
Yeah, it's just my photo again up. If that's the right one on my stream, I can't see it. Sorry.
I don't know. I don't think that photo really does justice to convince me that what you're saying is true. That's why I wanted to play around.
If you see my flicker, I'm following the sun up until it rises totally. You can see it right here. There is some refraction.
Your screen's not showing no more.
Damn.
Yeah.
I hate this Discord stuff. I'm gonna.
Sorry, dude.
I'm gonna go back to that one. Share screen. There. Now it's just a silhouette of the lighthouse.
There you go.
Yeah. So.
Do you have any ray tracing programs where you're modeling the light?
No, that's what you use in SketchUp for, because the drawing I had before, the orthogonal drawing to show how the line of sight goes. But again, as I showed before,
where's the azimuth, or where's the
here
the horizon?
There is the sun above the horizon. So again, I don't have a solar filter, but this is like 4,000 on 8,000ths of a second shutter speed. So the glare isn't that much bigger than the actual sun. But again, when it
what if I showed you a video of the sun setting? Oh, sorry.
Just pops up here.
Sorry, I thought you were done.
That is well below my eye level, because my eye level is well above those turbines. So
yeah, how do you know that though?
I showed that earlier.
Yeah, can you show it again?
I don't know. Did it change now? I need to make sure.
That's what I'm asking for. Where's the horizon?
I did my photo change?
Or the horizon?
I just need to ask, because again, Discord is messing with me. Did the photo change to the water tubes? Yes or no?
No, I messed up again.
No,
sorry.
To change it. No, it's just the same button, the share screen. If you're sharing, you just click it and you can change whichever source.
I have done it before, but I SketchUp, and the Discord is messing with me. So
no, all you got to do, instead of clicking the app, click on share screen only.
I do that.
Share the screen.
I have my screen number 3. Yeah, I'm sharing my screen number 3. But when I put another photo on it or Discord, it doesn't change on the stream.
All right, yeah, this photo right here. Let's analyze this photo real quick. I got a couple questions for you.
I need to have a drink.
So
I'm sitting here, but
because I've known about this phenomenon for quite some time now. I bring it up a lot, and there's something known as a vertical dip and a horizontal dip when you're looking through a theodolite or
this
any
is not a
optic.
theodolite. This is the camera.
Any optic, right? So when you mark up the screen, like preferably I would like to see where the horizon is, right? The horizontal measurement.
The horizon is below my eye level.
No, like right now, right? Like if you were to set up a station right now, a total station, or a theodolite, right, whatever, and you had a tripod, and you stabilize that tripod with a spirit level, right? Completely, and you got a plumb, and it's completely parallel, right, to the surface of the earth. And then when you look through it, there's an axis, right, a plus sign, basically crosshairs. You got the horizontal line. That horizontal line should be pretty close to the horizon, right? But what you'll notice is that usually there's a horizontal dip or vertical dip where the horizon is slightly below the horizontal line inside of the optic of that theodolite, right?
Yeah.
Now, why is that? You're gonna say, oh, it's because we're on a globe. The Earth curves.
Yeah.
Right.
Yeah.
But they've done the measurements without optics, and they found the opposite to be the case, where the horizon was at eye level. Now, what's interesting is if you start to consider,
I would really like to see that.
Now, earlier Taylor was bringing up sinking refraction, and you were talking about stooping refraction. Oh, if that was the case, the windmills would get compressed and concentrated, condensed, and they would all be mushed. Yeah, if it was stooping refraction, but there's other types of visual distortions, and it's not just a squishing effect. That's one of like 4 types of refraction, 5, 6 types of refraction.
But then again, you wouldn't have. Sorry, I'm just answering him, please. You wouldn't have all of those effects out there without it showing in the camera.
How do you know? If it's a clean gradient, why wouldn't it have a clean
distortions? Simple as that.
Look, I understand. Look, but if it's a clean gradient where the light rays have been upwards at a steady rate, you're gonna have a clean drop, bro.
Then you wouldn't have a clean photo.
This photo is so problematic for so many reasons. I don't know where to begin. You're dealing with
what photo are you looking at right now?
The photo with the water level.
Thank you.
And the horizon with the windmill at a distance, and the sun on the left.
Yep. Thanks.
Right. So right now, I'm supposed to trust you that you collimated this camera perfectly with the top of that water, right? With the horizon that's who knows how far away right there. Right? I'm supposed to believe that you collimated all of that together so that they're all lined up perfectly.
Collimated.
Yeah, that you lined up.
Yeah,
those like
up.
you
you
have
in the photo here. It's lined up.
Yeah, how do I know it's lined up?
You can see it in the photo.
Yeah, I would need another third. I would need a camera facing the camera that you're using right now for this observation. I would need a camera confirming that your camera, right? Your camera that you're taking the snapshot, that it's perfectly collimated, perfectly horizontal, and perfectly in line with the water level. That's who knows how many feet. Why do you have it 10 feet away? Why not put it right in front?
Because I can't focus on it then.
That's just going to add more problems.
No, it won't.
Because you can make it look like the horizon is below eye level. It's easy. We're talking about fractions of an inch. Just a little angle here, a little angle there. Boom. Oh, now you got the horizon below eye level. It doesn't take much, bro.
Stop, and I need to share. I promise you, I push my screen, but this damn dodo won't. There.
But not surveyors noticed this, and Alex Gleason documented this in his book. Whether you like him or not.
Do you see the back of my camera there?
Yeah.
Yeah. So this is what I do. That is still. That's the.
Yeah, that's the problem, bro. That's what I'm trying to tell you, though. The very thing in question is the camera itself.
I also have a bubble.
So for you to use your camera to confirm that you've calibrated the observation.
You're roboting.
I'm robotic.
But again, I have a bubble level here and a bubble level over there. I have the digital level there. I have the water level. How much more would you like to have?
Do you do that every single time?
No, that's fine. But that's not the problem. You can have it perfectly level, right? And when you're looking through optics with lenses, the horizon will always appear below eye level through the optic itself. But when you use the naked eye and you use a lensless scope, that means it has no lens, but it still has an aperture on one end and crosshairs on the other. You'll notice that the horizon is at eye level. But for some reason, through the lens, and what is that, a Canon? We probably got like a 6-inch lens on that thing.
It's right? The lens is
the horizon will most definitely appear below eye level with a lens like that. And even if it's perfectly stabilized and you have it all perpendicular to the ground, the fact that you're looking through a lens is gonna make the horizon appear below eye level, dude. Never mind the conditions of the day, like sinking refraction. That is very possible.
That actually, what you're saying there makes it easier when the water tube is like 4 meters away, I think. So when the tube is 4 meters away and I lined up there and it's still lined up with the tube, then the camera is lined up.
Yeah. No,
so
but you haven't confirmed that. You're simply asserting that. How do I know that the lens, the center of that lens, an APC full?
Yeah.
Is it a full frame sensor?
1.6.
Well, how do I know that water level, the very top of that water level, right, where the meniscus is perfectly lined up with the center of that lens, the center of that sensor?
I have zoomed in now.
The very barrel center of that sensor. How do I know that? How can I confirm that?
Do you see it on my screen? I zoomed in on that water tube.
No, I can't. Your screen's not on, dude.
I need to change.
So that's what I'm trying to tell you, bro. Like this has to be a very scientific, very precise experiment. And if your tripod's a little bit higher on one end, dude, and then where the water level is just a. Go ahead, dude. What are you gonna do, bro?
If I had anything higher than the other, then the water line wouldn't line up. I have tried it. Let me go to.
Bro, all it takes right now, all I would have to do, if I was a flat earther, is align my camera just probably under a centimeter higher, and it would line up with the horizon. Right?
Yeah,
if I was a glober and I wanted to prove globe, all I have to do is adjust my camera. We're talking about fractions of a degree here, guys.
Yeah.
To make the horizon either appear above or below. It would only take. We're talking about like the length, like the thickness of a hair, probably, because that's how far the horizon is. Any little bit of deviation is gonna make it look below eye level, and that's why I don't use any of these observations as evidence.
There, I did that. Exactly what you're asking for. If you see now this video playing on my stream, where the water is lined up, and I have some focus, some shaking because I'm adjusting the tripod.
This one looks better, dude. See, this one's on.
So just to show that the background is there, and I lowered the camera just a bit too much there.
But what we need is another observation of both the water level and the camera that you're making the observation with. You get what I'm saying? So that you can reassure us that it's truly at the same level. Right?
I'm adjusting the height.
And even then,
there.
Like I said, the lens itself is gonna distort the observation. The lens itself. This was confirmed in the 1800s. This was documented by surveyors that noticed this phenomenon, because at that time they were still using lensless scopes to make observations.
What if I do this?
But they notice.
What if I do this with a pinhole camera and the result is the same? What about that?
Yeah, a pinhole camera would be ideal.
Yeah,
it would be. It would be less prone to distortion because you don't have to contend with the lens itself. But the thing is,
But please watch the video now, because I do this. What you're asking for.
You still have the atmosphere. You still have the atmosphere.
You actually did do it with a pinhole camera too.
No.
Oh, okay. I was about to fucking give you a fucking medal. Oh my god.
Yeah. I just
no, but I was gonna tell you though that you still have the atmosphere conditions to contend with, bro. Like like not necessarily humidity, but evaporation, water vapor, right?
This
you have
is
light
hogwash.
attenuation.
This
not,
is absolute hogwash.
not because when you have bottom up obstruction, dude, bottom up obstruction it's not just one thing that causes that
just
phenomenon.
Just keep to one topic, and you said the water, something humidity or what it was. Then there would be difference again in my observations, and they are not. But as I'm trying to show you on the video now, if you see what's happening there, now the water doesn't line up in a tube at the horizon. I lowered I raised the camera a bit. So now you see the water lines up with the horizon, but now the water doesn't line up in the tube. So it's really easy
it looks
to
like
do
it
this.
lines up to me, dude.
Now
is it just me, guys, or what? What's going on? Yo, listen, this is just it's inconclusive, dude. That's all I gotta say. This doesn't prove anything.
It's definitely inconclusive.
I did exactly what you asked for. I raised it and lowered it. Exactly what you asked for.
Inconclusive. Sorry.
Sure it is. What you ask for. Don't be there.
Moving the goalpost.
Yeah, that's exactly. Thank you.
On what grounds is it being claimed to be inconclusive?
We can't believe
it.
this. We can't believe this. It's been taken with a camera, apparently.
I did exactly what you asked for. I moved it up and down to show that the water
already,
in the tube changes
dude.
with the horizon.
This is what
there's so many problems with optical measurements.
That's why
optical measurements, whether it's a camera or a theodolite or a total station, you're gonna have problems, guys.
We can't make scientific observations with a camera. It's just not possible.
Yeah,
then again,
it's
Lion,
impossible.
if I can ask Lion a question, would you say that no observation ever made can be done to justify to figure out the shape of the Earth? There is no observation out there.
It's inconclusive. All the experiments that you guys have provided thus far, in my opinion, are inconclusive.
So what would you do?
They can go. They can sway either way. Actually, there's biases.
What would you
in
do
some
to
of them
figure out
that
the
you
shape
guys
of the
refuse
Earth?
to acknowledge? Excuse me?
What would you do to figure out the shape of the Earth?
Get far enough away from the surface.
Yeah, I can't. Yeah, I can't. I can't confirm with 100% certainty the entirety of the Earth.
How do you figure out the
I remain agnostic on that, but I do lean on the fact that locally, right, in my natural observations appear to show me that the Earth is planar, that it is flat. For lack of a better word.
But how would you?
And I think, Lion, have you held up a tube of water, a long conduit with a U-bend of water like that to the horizon and looked with your own eyes?
Yeah, I've done a lot of little experiments on my own. I have my own camera.
And does
Canon XH1S.
not with the camera. You can't trust the camera. I asked you, have you got a long? What he's just done there, get a long U-bend of water and line it out with your own eyes to the horizon.
Yeah, it's expected it would be above it. That's what a dip angle is with a sextant. That's how it works on a planar surface. The horizon is below you.
Why is he going on about
not perfectly at eye level? It's below you because you're above the ground. It would be at eye level if you were like a centimeter from the water. But if you're 60 feet up, 22 meters he was, over 60 feet.
Yeah, 72 feet.
That's how that functions. You're above the ground, looking slightly down at it.
And why is Lion going on about not being able to trust that because it comes through a camera?
Well, I agree with. I was only maybe partly listening in and out, but I agree with what Lion's saying. It's like a centimeter of adjustment. So I think he's just talking about the exactitude to try to claim an eye level over 60 miles.
The viewing angle, because you have the observer angle, the viewing angle to the horizon itself. You got the angle of incident, you got the viewing angle.
But if
the observer angle. That angle, you have to make sure it's collimated perfectly to the horizon, that it's horizontal, that the water level is completely in line with the sensor itself, right?
Yeah,
and then you have to consider the lens itself, how the lens distorts the observation of the horizon, how it's going to make it appear below eye level, right? And then you have the atmosphere itself to contend with, right? With the gradient densities that Taylor was talking about. All these things combined will make the horizon appear below eye level, and you guys keep throwing it in our face Like, dude, these observations are inconclusive, dude.
No,
Thing is
like,
that
what? You have anything else?
The lens is. Please let me answer.
On.
The lens distortion you are talking about, this collimation thing, that happens inside the lens. Nothing happens outside the lens. So from the lens to the water tube, the tube is lined up. Whatever happens behind that have nothing to do with the lens.
So nothing. You just said nothing, bro. You haven't confirmed and reassured us, right, that camera is actually perfectly in line and collimated with the water level. You have not showed that. You don't have another.
So he needs a secondary camera to observe his setup. And that would satisfy you?
Yeah, we need it. Yeah, it needs to be more systematic.
Lion.
Any little deviation, right, from the center of that sensor to the water level is gonna get it's gonna get your globe.
Please let me answer you.
It's not science.
Take a beat. Let me answer you. I showed you 3 different methods I used. I had 2 bubble levels on the tripod. I had a digital level in the camera, and I had a water tube 4 meters away. How many more different ways do you need to have that camera level?
Oh my gosh, dude. You can't be that serious, bro. The water level is logically irrelevant, right? Because even if I granted you that you had it perfectly leveled, right, according to the spirit level on the tripod, and that even according to the digital level inside the camera, it was perfectly leveled, that's all logically irrelevant, because then...
Again, lens distortions happens inside the lens, not outside. So whatever happens between the lens and the water tube doesn't have after the water tube. That's not lens distortion. That's not collimation. It just doesn't work like that. It was. I showed you it was perfect. I showed you it was perfect. No. I wasn't caught. You don't understand lens distortion. And the level inside the camera and the 2 tubes on the tripod, yeah. What about the digital level on the camera? What about the... Yeah. And then making sure that it's perfectly leveled with the water tube.
The camera, that sensor has to be perfectly in line with the water level.
It was.
How do I can't know that just by looking at the spirit level on the tripod.
I showed you.
You didn't show it.
How can he reassure us?
I showed you.
How?
Show it again, because you're not. I don't think you're getting what Lion's saying, man.
Oof.
Well, can I just say too? Here, I'm about to post something in the chat. This is something actually part of a drawing that Rumpus, some of you may know Rumpus, some may not, from many years ago. I'm just going to post it real quick. But over a planar surface, this is like a zoomed in little cut part of it. See how that pink line is angled down? On a planar surface, the horizon is going to be down from where you're at if you're above the ground. That's what a dip angle is in celestial navigation, because you're looking at the ground and you're above the ground. So over a planar surface, the horizon is not going to be perfectly at eye level. The horizon will be below eye level. If you're 60 feet above the ground, 100 feet above the ground, depending on how high above you are, that's why they account for it. It's called the dip angle in celestial navigation. It needs to be accounted for. So over a planar surface, it would be expected that if you had a perfect level from your eye, that's going to be above the horizon, just a very slight amount. Remember, the ground is beneath your feet. So if you're seeing the horizon as, the water, whatever it is that's out there, that is technically below your eye level over a planar surface. You're looking down at the ground.
I would say that what the small thing you have there is far out of. Again English words. It's not to scale. That angle there is something really short, as I had with my orthographic painting.
Yeah, so, it would be much less than that. That's a dramatic. That would be a horizon. That would be a horizon that's 30 feet away. I hear you. It would be less, but I'm just saying you're still looking above it. So I'm just saying in general, that's one thing to be expected. The other, I'm just saying that over a planar surface, that's what a dip angle is. Depending on how high you are above the ground, you're always going to be looking down at the ground by a little bit. So perfectly eye level, parallel to the ground, is going to be above the horizon, because the horizon is the meeting place of the ground and the sky, the main part being ground. Therefore, you're above the ground looking parallel to the ground. You're going to have to look down by just a teeny tiny little bit in order to see the horizon.
Yeah, but there's been people who have taken that dip angle and calculated it. When you graph it up, you get a globe.
All right. Well,
they've reverse engineered the way our eyes work to claim the globe.
They've reverse engineered the dip angle.
Yeah, remember.
Well, that's part of it, is the geometry. The other thing I wanted to say, though, it seems like you focused you're focusing on this eye level as being why you're correlating to a globe, these observations. But I just want to, and some of the contentions around it are being brought up, but I just wanted to address too, one of those pictures you showed actually showed a significant portion of that hill in which the wind turbine was on top of. That shouldn't be possible on the globe Earth. There's supposed to be 200 meters blocked, which the hill only goes to 175. So that hill should never be observed on the globe Earth. And one of your photos shows the hill. So sorry to say, but you've kind of, in a way, debunked yourself, because the fact that you can see that hill in one of your shots shows that, the quote unquote see too far, meaning see too far for the radius of the globe, is actually in one of your photos.
But then again, you used 8 inches per mile squared, right?
Yep.
I used incorporating the 22 foot, 22 meter observation height, which is a little over 60 feet.
You can't do that to 8 inches per mile squared. That's not the right way.
Well, that's just basic Earth curve calculation. I didn't say I used 8 inches per mile. I'm just saying the actual Earth curve.
What did you use?
Well, there's a lot of different ways to calculate it, but I just used one of the.
Well, hang on.
Show me the numbers.
Where's your north then? Where's your reference? Where's your reference, Hotshot? If you're not using drop over distance, what are you using for a reference?
Don't get at me now.
I mean, do you disagree that the map is 200 hidden? Is 200 meters? What's your hidden? Because that's what it is for that distance and observation height. Do you have a different one? 200 meters should be hidden, which means you should never be able to see the hill. And in one of your shots, you could see the hill. That's what I'm pointing out. You can see the whole hill.
I'm just asking what calculations you did.
Look at the windmill on the right, far right windmill and water. You don't see the entirety of the water, you see the whole sky.
Who are you addressing, please? Are you addressing Gio or me? I guess not.
So it sounds like the false assumption was made that light can and only ever goes perfectly straight, which is an objectively false assumption. There's numerous examples.
I'm not saying that. The thing is, though, according to refraction, what my prediction needs is just about the light bending a tiny half a degree or something to match. On the flat Earth model, it needs to bend like 5, 6, 7 degrees the wrong way.
Exactly. What's interesting about this idea that the horizon should be angled down even on a flat Earth, if you put a point on a surface at a distance and you're looking at it from a certain height, it will have a certain angle on a flat surface, but on a curve, it will have twice the drop angle, which is something we can measure.
No, we went through this other day. You have 0 measurements, remember? That was my favorite part.
Yeah. We know that you define everything that you disagree with as a not measurement.
It's just not a measurement. You don't have any measurements of which way the light's bending. And this guy just debunked the globe radius with his own picture. If you're saying that's your measurement, is that the measurement or no?
Measurement of what?
And anytime you guys do any optical thing, whether it's reciprocal zenith angles or any kind of optical measurements, you always debunk the globe radius.
Well, I'm curious, but by your standard of measurement, Jeremy, does this also mean that there is zero optical flat Earth evidence or measurements as well?
Yeah, I would say that there are no the only measurement that exists right now is of level not curving. There is no measurement of plumb lines diverging or converging. There's no measurement of drop over distance. There's no measure of level curving. We do have measurements of level, and it's not curving. That is actually the only measurements that exist of level.
And plane surveying as well.
May I ask a question? So in the white part here, any of you who have any type of measurements or anything, what would be the correct way to discern the globe from the flat? What method should we use?
Figure out if level's bending.
How?
How about measure water curving in 1 mile?
Using what?
Establish a plane. Well, go ahead, Jeremy. If you, I establish a plane of reference and compare it to water.
Or make a mold of the level. Like, we've kicked around different ways to do this. It's obviously very difficult. We have to get rid of the optical stuff, though, because you guys don't have any. There's no measurement of which way the light's bending. Everyone just has a guess or a good idea of which way the light's bending over miles and miles, or a mile or 1,000 feet or whatever it is, but nobody actually knows because there are no measurements of it.
If you can't do any measurements or visual, how should we discern Earth being sphere or flat? What should we do?
I mean, you're coming to me for this. I could give you a bunch of ideas.
Sure,
I could give you a bunch of ideas, but I mean, they should have already done this, though.
Yeah.
Except sending people into orbit.
You want one, dude? If you believe that, I mean, this ain't.
No, I said except from sending people in orbit. What should we do?
How many people have been
dude, going up high? Hold on, Eden, hold on. Going up high doesn't tell you anything.
Cool. The
horizon on a globe is geometrically flat. Like that ring around the edge, that's on a plane. That horizon sits on a plane.
Okay.
It doesn't really tell you much going up high. So going up high doesn't tell you anything.
No, that's exactly what I said. Except for going up high, what should we do?
Well, if you want
there's a bunch of ideas. There's a bunch of ideas that we could kick around to you. We got Jesse knows one of them is pulling a line, a neutrally buoyant line through water. We have other ones where we make a mold. We draw lines on a wall. There's a bunch of different ways to do it tangibly that wouldn't involve the long range optical. There's a bunch of ways to do it tangibly that wouldn't involve the long range optical stuff where you don't have a measurement and you could actually end up with a measurement.
You said that line, that would have to be stretched like so hard it would snap in an instant, right?
No, you do a neutrally buoyant one. You don't really have to. It would basically be like a plumb line horizontally because there's no forces on it.
So it's just floating on the water then, or what?
You do it inside the water. Well, the way to do it would be to do it in the water, not on top, inside.
Yeah, but then you have some currents and waves and all of that.
One side.
So how do you measure if that is straight?
1 foot deep on one side. Obviously, you wouldn't do this, my man. You obviously wouldn't do this. You would do this in a very calm canal or man-made body of water or something that wasn't tides and waves and stuff.
Okay.
But you would take 1 point, you'd go 1 foot under the water and secure that there in that location. Then you would go a mile or however far you were doing this, go 1 foot under the water there, secure it in that location, and then pull it tight. And then you measure it on both ends and in the middle, and that might give you a good idea. There's tons of ways. We've been talking about this for years now. I mean, you'd have to clear your schedule for the week. If you wanted to hear them all, you'd have to clear your schedule for the week.
Yeah.
So the first one was you need a mile long.
Why haven't anyone done it?
It's not easy. It's
it kind of
easy.
reminds me, why hasn't the government produced one uncut video from Earth to far enough away showing the globe?
Give a fuck about the government. I don't care about the government. We can do this by ourselves, can't we?
No, that's what I'm saying. Well, the government has already spent over $1 trillion and they've had 4 decades. We don't have one uncut video. That's a red flag.
No, I don't care about the government. Let me be honest here. Have you ever seen any?
Well, you mentioned orbit.
Please, let me ask you.
A minute ago. You mentioned the orbit though, so it seems like you do care.
I said except from going to orbit, yeah. But have any globe earther, as you have seen, ever used anything from any government or NASA or anything to prove the shape of the Earth?
Yes, but not recently, right?
Yeah.
Because they know that you can't trust them.
Yeah, we don't bother because you don't trust them. You don't.
Do you trust them? Do you trust them?
I don't care about the government.
Do you trust them? Yes or no?
They lie all the time, so no.
Okay, thank you.
Is the Norwegian government lies exactly as much as everybody else, I guess, but no. I do my work myself.
I feel like I'd rather have the Norwegian government lying to me than the American government.
Yeah, we lie about
I feel like that's a safer bet.
Yeah.
At least we could get
But
at least
Jeremy,
we could get lutefisk handouts.
Jeremy, another just something we can do. Just put our shoes on and go outside to make anything observations or anything.
No, there's no optical stuff you can do because you don't know which way the light's been. And in order to know which way the light's been, and you have to measure which way the light's been. And the only way to do that is using something that's not subject to refraction. So you're not going to be just going outside and looking at something because you'll debunk your globe radius immediately.
So
like you just did in your own picture that you showed that Geo pointed out how you debunk the globe radius.
How did you figure
that
out
was like 5 minutes ago. Remember that? That was my favorite part of the last hour.
How did you figure out the Earth was flat?
Well, I mean, I went down a very long road, and I'm just going with what measurements we have. And like I said 2 minutes ago, we only have there is no other measurement other than level being a horizontal line. Like there's no measurement of level curving. It doesn't exist.
So you don't know then?
I'm not 100%, but I'm very. There's other things too. Like, dude, it's been a long road, man. Like, there's been a lot of stuff.
Yeah, but if you have figured out the Earth is flat, there must be some reason for it, right?
Yeah, I have multiple reasons. Multiple reasons.
What's the best one? What's the hardest hitter?
Dude, I don't have like the best one is the only measurement of level is it's horizontal. That is the best flat Earth evidence in my mind.
Where was those measurements?
Measurements. We're talking about a geometric, because this is a geometric claim. So, it's all about the measurements, baby.
Yeah.
Well,
where was those measurements taken? Who did it? What was it?
Could I say
level? They do it every day. They do it every day, and no one's ever measured level curving doing it.
But
you can do it yourself right now for probably like $10-$20. You could probably do this shit yourself.
But you said measurements wouldn't show.
You can measure level. It wouldn't show It wouldn't show the difference between globe and curved. However, the only one that exists as of right now is of flat. So,
how?
Like your shit don't exist. Ours exists.
I'm sorry. I'm not gonna say anything wrong about it. But have you been listening to Nathan Oakley?
No, I haven't been listening to Nathan Oakley.
Thank you, because he's the same thing. But if you said Earth is measured flat because reasons, I would like to know those reasons.
Because there's only a measurement of level. Well, I have many reasons, but the best one is the only measurement of level is it's a horizontal. That's the best one. There is no measurement of level curving.
So Earth is flat because dictionary.
No, I'm talking about real world measurements. Like you can go do this right now on a wall. You can go measure level being horizontal. Everyone can go do this.
Level.
What you can't do is measure it. What you can't do is measure it curving. You can't do that because it doesn't.
So reciprocal sinus angles.
But you can't do it.
Reciprocal sinus angles.
Yep, the plumb lines. We can go there. If you hang two plumb lines on a wall, they're not diverging or converging. They only measure parallel. When you guys go do reciprocal zenith angles, you have to add in refraction, just like with the picture you debunked the globe radius with a minute ago. If you don't add in some amount of refraction, you'll debunk the globe radius. That's not a measurement.
Then again, you haven't measured it flat.
They actually use reciprocal zenith angles because they know how much they should be diverging and converging by, and they tell you that's how you can get a refraction measurement.
But then again, you haven't measured it flat. If you do that on a wall, it's just a couple of meters. You can't measure anything on a couple of meters.
Can I ask a question?
Sure.
Is Jeremy's claim that because there's a lack of what he considers valid globe or curve measurement, that therefore that lack of curve measurement qualifies as measurement of flatness?
There is no measurement of curve. You have zero measurements, Jesse. We just did this like a day ago. It was like 2-3 days ago, maybe. You have no measurements, dude. It's embarrassing. I feel bad for you, honestly, a little bit. Kind of, not really.
He did ask a good question. Does that mean it's flat, or does it just mean it's just no curve? Like, what does it mean to you?
It means that there's a lot of things that have led me to believe that it's flat, and that there being no measurement of curve is one. That's a big one. That's pretty big, because we only have a measurement of level not curving.
It sounds to me like you said that Earth is flat because dictionary.
No, because of real world measurements, bro. We just did this. I said because of real. You said this 2 minutes ago, and I said no because of real world measurements. You can go do this right now.
So when they measure,
you can go measure. You can go measure level not curving. You can measure level being horizontal, not curving. What you can't do is make a measurement of it curving.
So when you measure the zenith angles and you get over 180 degrees, that's not good enough.
We just went through that, dude. We just went through this reciprocal zenith angle thing too. But it's like, are you even listening to what I'm saying?
What you're saying is contradicting yourself.
I feel like we're having Groundhog Minute or something. Like,
because you are contradicting
yourself. I just answered all this stuff you're asking.
You are contradicting yourself.
Okay, Tommy, can you use spherical
Where's
geometry?
the contradiction? Well, he's just saying I'm contradicting myself.
Because when people measure the zenith angles, they get over 180 degrees. That's been done.
Tommy.
So
Tommy,
I'm just answering Jeremy, please.
Hold on, Eden.
I'm just answering Jeremy. When they measure those zenith angles, they get over 180 degrees. And if you claim that that is just refraction or anything else, then no measurements ever will measure anything. So you can't say it's been measured flat, because then the measurements doesn't count anyhow.
Okay, that's not me contradicting myself. When you do these reciprocal zenith angles and you make an angle measurement and you're saying the angle is the measurement and that's it, you debunk the globe radius just like you did with the picture you showed 5 minutes ago. And Gio pointed out you shouldn't be able to see the hill. If you do add refraction, now you're saying, now I know, that's how I know you don't have a measurement, because you would have had to measure which way the light was bending, and you don't have that because you'd have to do that with something that's not subject to refraction, which is insanely difficult.
Yeah, so how can you say it's been measured flat? It hasn't, because you can't trust in the measurements.
I said the only measurement of level is flat.
How did that happen?
When you measure level, you cannot measure level curving. There is no measurement exists of level curving. I said that was a good piece of evidence, or that's what led me to believe. That's my favorite thing. That's my favorite thing that brings me to where I'm at now.
What are you measuring to? What are you using to measuring level?
You can use a water level. You can use a water level and a spirit level.
A 1 meter. What level? Are you serious? A 1 meter.
You can go 2 meter. You can go 2 meters and you still can't measure. You can't measure it curving. The only measurement, I'm not saying this says this is a measurement that shows us Earth is flat. I'm telling you, this is one of the good evidences that leads me to believe that it is flat, because the only measurement of level that exists is of it not curving, because you can't measure it curving. You can only measure it flat.
So how does a 2
It's like you're not listening to me. That's like the 4th time I've said that.
How does a 2 meter long water level tell you that Earth is flat?
Look, you take a tube.
I didn't say it tells you Earth is flat. You're not listening, bro. I gotta dip on this because you're not even listening to what I'm saying. I don't.
How does it tell us level then?
He's focused on a spirit level. Like he's focused on like a little handheld spirit level. All right, take a tube, right? Just think of this concept. Take a tube, however long you want, fill it with water, right? The water will come to the same height in both tubes, on both ends of the tube, right? It's called a level, a water level.
Yep.
So you can extend that 5 feet, 10 feet, however long, depends on your tube, right? So it's not like a little handheld spirit level you're thinking of, like Home Depot or whatever hardware store you shop at.
What happens if you have 3 or 4 or 5 outlets on your water level over many kilometers?
Then you have,
hey, does
I don't know, pretty good water level? Like what?
No. So
What are you
that's
asking?
your onus, right? To prove that they're all in a straight line. You can prove 2 in a straight line easy, right? But 3, 4, 5. Yeah, you need 3, 4, or 5 to determine whether the straight line is a plane or whether there's some other shape to it.
Like a 5-sided die. Yeah. Yeah, you can actually do this when you're building shit, right? You can actually build something.
You need to do.
You can't do it when you're building something. You've got to do it bigger, right?
Yeah.
Yeah, but instead of having like that water level, have like what 5 outlets, you just have 2 outlets, right? And you just create like a reference point in the center. And you just keep it in the middle, and then you just rotate it like a clock, and you just swing it around so you know all points are level, right? And they'll all be in relation to one point. And then if you can get everything level after that, and then go with like a 6-foot spirit level or something, and then you can confirm that, well, you would just know water doesn't curve.
How about this? You have that water tube, a long one, and you have the third one in the middle. That's your reference point.
What?
You just have the long tube. Let's say 100-meter long tube. In the middle of that, and 50-meter, you have the third tube sticking up. Then you have a reference point.
I mean, it's redundant.
No. Oh, no, no, no. If you have 2, you can't tell.
Dude, I just told you how to make a circle with a water level and check all parts of the circle to see if they're level.
No. You're not
saying no.
understanding the problem.
You're saying
Any
no.
2-point water level will form a plane. You need a 3-point concurrent water level or more to truly understand whether that level surface is planar or not.
2 points.
Yes, I would agree. I would agree to that. You got to do 3 points. You got to do 3 points so you know where the middle point is.
Yeah.
That's what I'm saying.
you
You
need
can
to measure
only
them somehow,
anytime
right?
you do this with 3 points, you can only measure it. Like all that long range optical shit don't count, dude. That's not a measurement. If you're saying that's a measurement, angles or whatever, you're debunking the globe immediately. You have to add in
So
refraction.
that's
You have
going back.
no measurement of which way the light's bending. Hold on a second. That's what I was saying. The only measurement of level is of it not curving. Like go do that. Go get a spirit level with 3 points and do a measurement. It's never going to curve. Or you're never going to measure it curving because you'd have to go for so far. Even in your own model, you'd have to go a half a mile, 100 yards. Like you're never going to be able to do that on the short thing. I realize that doesn't mean Earth is flat. I realize that doesn't mean Earth is flat. I realize this doesn't mean Earth is flat, but it does mean the only measurement of level is of it not curving.
No, you're in the same boat as trying to show the curve here, right? That scenario you described is equally unable to show those things being planar as it is shown for them to be shown to be curved, right? You have the same problem, which is what the other guy was saying. That if you claim that you've measured,
I don't have a problem. Sorry. I don't have a problem. I'm just saying that's the only measurement is of level not curving. I realize it doesn't show that Earth is flat. I understand that. Please stop trying to put that on me. I wasn't saying that. I never said that.
It sounds like it's what you're saying.
Yeah, same here.
No, I'm saying that's a good evidence. If Earth's a globe, level has to be curving. There are no measurements of level curving. That is a good piece of, that is what led me to believe that it's not curving. Because shortly there would be measurements of it curving, and you guys don't have any.
How can you figure it out then? Tell me one method to figure this out.
I gave you one with the neutrally buoyant line, bro. Are you even listening when I talk? What's your favorite
you can
color?
do with your feet on the ground.
What's your favorite color? Yo, what's your favorite color?
Something you can do with your feet on the ground.
My man, what's your favorite
53,
color?
I don't have a favorite color.
All right. Well, at least you're listening for the moment. You might have. I don't know.
I'm a grown man. I don't do that.
Yeah, I'm a grown man too. I'm a grown man too, and my favorite color is clear. Now what?
Tommy, I had a quick question. I've been trying to ask the Globers here. Do you believe that you can do spherical geometry on an asymmetrical boulder?
On an asymmetrical boulder? You can measure it, can't you?
Well, yeah. Would that introduce errors, in your opinion? Yes or no?
I have no idea.
It depends on the amount of asymmetry. If it's
errors,
okay, so
there will always be error in mid-space. You don't have anything 100% never. So errors,
okay,
yeah, but what kind of errors? That's the thing.
Yeah, because according to the axioms of spherical geometry, one of the axioms is uniform curvature. So if you do not have uniform curvature, that's obviously going to introduce errors.
I already told you, John. We talked about this. I already told you. The claim is that the Earth is like 0.3% wider.
Is your name Tommy, Jesse?
Hold on. This is a public forum. We take turns.
I know, but I would answer exactly the same. I would answer exactly the same. The difference is tiny.
You're straw manning the globe, okay?
How do you know that, Tommy?
So, Eden, the radius of the Earth is like 6,371 kilometers. With that, is it 24 kilometers or something difference to the radius at the equator? That's nothing. If you have a picture in full size on the screen, it's less than 1 pixel difference.
I mean, I think the main focus is. Oh, go ahead.
Oh no, let's go ahead, Jeremy. Thank you.
If you need a problem with geography, you just go back to school. Not geography, geometry. Go back to school.
I mean, I think the most important thing that everyone should take out of this is that you guys don't have a measurement, and that's not. We're just some dudes on the internet. Like, this is like, we're talking about like the globe, the mainstream. Like, there's no measurement of level curving. It's crazy.
Well,
you mean not one you accept?
You see you think.
Sorry, what?
You denying it? That's a you thing.
No, I'm not denying it. It's just the optical things that you bring forward debunk the globe radius. If you're saying that's the measurement, if you're saying, well, there's refraction too, you don't have a measurement of which way the light's bending. So
you would
that's
say
not me denying anything. That's not me denying anything. That's you not having the thing that you think you have.
So you're saying that surveying doesn't work then?
Sorry, can you repeat that?
You are saying that surveying doesn't work.
I didn't say that.
And so how does surveying work then? If you can't trust the atmosphere?
I mean, what do you mean work? Everything we build on Earth uses rise over run. You know what that rise over run is? You know what rise over run is? It's flat Earth. It's flat Earth.
English geometry. I'm sorry, I didn't have English geometry in school, so I don't know what that is in Norwegian. Sorry.
It's the same. I'll tell you. Do you know what y equals mx plus b is?
What?
Do you know what y equals mx plus b is?
No.
Well, there's a lot of stuff you don't know, my man. I can't teach this all to you right now. It's the slope-intercept formula. Rise over run is how we build everything on Earth. It's the same thing as that formula.
So when
you get an elevation, off a plane, a horizontal plane, elevation. Guess where that doesn't work? On a globe.
I'm not quite sure if you know how surveying works.
Planar surveying? I know geodetic surveyors are full of shit. We went over the arc of the parallel. We went over the arc of the parallel for about fucking 2 months combined.
You have
there was no measurements in that. Ironically,
you have a total station on top of a tripod, right? And the target is on a tripod. Whatever is below that, if it's curved or straight or bumpy or whatever, the total station doesn't matter. So there is no horizontal or anything you have to take into care there. You just measure point to point.
Yeah, if you do that, you debunk the globe radius, like when they do reciprocal zenith angles.
No.
Like when they do reciprocal zenith angles. Yes, you would. If you said, I just take an angle measurement, that's my measurement, you will immediately debunk the globe radius.
How?
Because if you don't add refraction, the shit is not where it's supposed to be geometrically. Even in reciprocal how many reciprocal zenith angle measurements have you gone over personally?
That's a good question.
I was a surveyor from 1994 to 1999 building the Oslo Airport Gardermoen. So,
oh, that's cool.
Yeah. Okay, how many times have you done reciprocal zenith angles?
Honestly, I don't remember.
Oh, you've done it that many where you don't remember? Okay, fine. Do you always get the globe radius when you take your reciprocal zenith angle measurements for how much the plumb line should be diverging and converging?
The area of Gardermoen is 13 square kilometers, as in 5 by 3 kilometers. We didn't care much about that.
I think you're talking about
that's what I'm saying. If you did care about that, you would realize that these reciprocal zenith angles, if you're saying just make the angle and that's the measurement, immediately debunk the current globe radius.
That's you saying it.
Well, that's a fact because I've gone over. That's a fact because I've gone over reciprocal zenith angles and you haven't.
If surveying is as bad as you want to have to be, it wouldn't work. Sorry. Surveying works.
I've gone over reciprocal zenith angles.
They build tunnels without refraction. Tunnels along the England France tunnel. What refraction do they have there? It works.
Okay, I've gone over this reciprocal. We're on tunnels now. Do you concede that this reciprocal zenith angle thing would debunk the globe radius immediately?
I'm just saying that surveying works.
Okay, and I'm showing you where the problems lie. You want to just jump around all different topics and stuff. I mean, if we could stay focused, that would be handy.
We're talking about surveying, and it works. It's being done all over the place. All the time.
Reciprocal zenith angles in surveying, yes. But you're trying to now jump to a tunnel, or I don't know. You're all over the place. Can we just
because
focus?
You don't have much refraction inside the tunnel, do you?
Okay, how are they doing it in the tunnel?
Measuring.
How?
Degrees, angles.
And what? Just digging it? You're saying they're digging down, and they're popping out on the other side?
They met each other at the middle, didn't they?
I'd like to see how this is done. You got a
the tunnel is there.
Can you just run? Can you just run through? Yeah. Can you just run through like me and you? I'm in France. You're in England. What do we do?
We measure through the ground.
What do you take the measurement with?
A total station, and some reflectors, and you make markings, and you blow.
So you just angle down. You just angle down, and you just start digging down.
Whatever angle it takes.
And then you go in a straight line and meet the other people.
Curved. That's curved. It's curved both.
So you don't make the tunnel. So you don't go in a straight line.
How can you do that? It's under the seafloor.
Yeah, under the seafloor. I figure it's wide open. You can go in a straight line. No.
No, it bends.
What bends?
The tunnel.
Why does it bend? You're under the seafloor.
It needs to go down, it needs to go up, and it bends sideways. Just look it up. It's
there. Man, this shit is like one of those swirly straws you had when you were a kid with the chocolate milk.
You don't believe the tunnel exists, do you?
I don't know. I'd like to see. Do they have one that's straight?
I don't know. Many straight tunnels, yeah, but tunnels work. Surveying works. If you don't think surveying works, then I'm sorry, you're just way off.
I think there's major problems with geodetic surveying. Are they using? You're saying they're using geodetic surveyors or planar surveyors when they make these tunnels?
What do you think?
I don't know.
Yeah,
that's why I asked.
It doesn't matter. It really doesn't matter.
Yeah, what? What do you mean?
I think, well, for that instance, they they have to use.
You don't know anything about this, dude.
Global or what do you call it? Yeah, this English thing, global surveying. Yeah, because you need to take the Earth's curvature into consideration.
Oh my God! People just say that all the time. I know.
Yeah. Could I say something real quick?
Sure.
Just more saying stuff, no measurements. Go ahead, Jesse. Say more stuff.
Since the topic of reciprocal zenith angles was brought up, my brother and I did do a simultaneous reciprocal zenith angle. We were each at 6,000 foot elevation on a mountain peak. Well, he was on a peak, I was on a ridge, and the distance was 7.2 miles.
And how much off? How much off? When you did your math, how much off of the globe radius were you?
0.08 or something.
Jesse, how much of the globe radius were you off when you did the math?
Which math?
Oh, you didn't do the math for how much the plumb line should be deviating according to the height and all that and the distance?
We strictly measured the angle as measured by the theodolites, and that I have to report.
We'll report it. I want it on my desk by tomorrow morning. No, seriously, you didn't do the calculations? When did you do this?
Hold on, let me get the image, and then I think the date's in there. Hold on.
Just drop that shit in the chat. They'll run numbers on it in like 5 seconds, bro.
Just in my head, it's like something like 0.08.
We'll see how much you were off. We can see how much you were off. We can see how much, if you're saying that's the measurement, we can see how much you debunked the globe radius by.
So the date was 10/12/2024 at around 1500 hours, it looks like.
Are you sharing?
And we both, I just put it in the text chat.
Okay.
And we both measured about 2 arc minutes and 36.5 arc seconds of down tilt to each other simultaneously, like at the same time.
All right, well, let's get those numbers crunched and figure out how much you debunked the globe radius by. What do you say?
Let's just say that refraction up there is minimal, like nothing.
No, we're not doing refraction, bro. You said that's it, right? That's the measurement, the angles.
That's just the angle of the light, the incident angle of the light upon the instrument. There's no corrections for refraction. That's just the raw angles of the light as it entered the instrument. So if you assume that light took a straight path when it did not, then this will not match the globe radius exactly. But if you take into account the physics of the speed of light in different in a pressure gradient, then I think it comes pretty close to the globe radius.
Cool.
Yeah, but we know that thing's not geometrically there, though. So the problem lies is which way is the light bending and by how much. And now we're back to not having a measurement.
Again, at that elevation, the refraction and everything else is really about nothing.
You don't know how much the light's bending, my man, because you don't have a measurement of it.
Actually,
you can just keep saying, "Oh, it's not that much," or "We're pretty close," whatever you want. But we're back to you not having a measurement again. That was like 10 minutes ago. Remember that?
Actually, standard refraction is very close to what you get even at that elevation.
Okay.
In fact, my personal world record was from about 9,000 feet to 14,000 feet at 105 miles, and standard refraction even was spot on for that. A single face left, face right, apply standard refraction in Earth curve, I was within 18 feet of the published height.
So I agree that there could be some standardized like atmosphere, but like, which way is the light bending in a standard atmosphere? Like, what was their elevation when they came up with the conclusion of the standard refraction? Like, where did they take temperature measurements from and at what time?
Well, I mean, that's a multifaceted question because a lot of different people have calculated in a lot of different times over the last 300 years.
This is the time that you're referencing.
This is being measured and calculated over, as he said, centuries. This is not just one guy said this and that's that. This has been done.
Well, actually, there's different
ideas of stuff. Right. Of course, there's variations.
So if you want to derive it objectively yourself, what you do is you measure the temperature, pressure, humidity, and CO2 content, which you can ignore if you want. It makes a very small content. You can measure that at two different elevations and measure the height difference between those, but do it where you're actually measuring just the air temperature and not the radiant temperature from the surface, because that'll throw you way off. Because anyway, compensate for the difference in your, the offset in your differential temperature measuring. Then you can calculate the speed of light at each of those two different conditions. Then you can calculate how many wavelengths will be in a given distance. So you'll know that, like, let's say you measure your temperature, your metrology stuff at one elevation and then say 1 meter higher. And then you can calculate the speed of light at the first elevation and at the 1 meter higher. You can then calculate the change in wavelength, and you will calculate that the wavelength, if your line of sights are up high above the surface, you'll calculate that the upper ray will be traveling faster and thus have longer wavelengths. So all you need to do is then calculate how much curve those two concentric rays have to make in order for them to line up at the ends, at both ends, and be equidistant. And then that is your amount of curve.
Damn, that's
or your amount
nice.
of refraction.
What's that?
I said, or your amount of refraction.
Well,
that's
right.
How you calculate it.
That's the amount of the curve of the refraction. Yeah. Because it's a simple matter, light has a wavelength, it's got a frequency, and when a ray of light travels a path, it does so as a parallel wavefront, and if one side of that, the upper side of that, for example, is traveling faster, that will curve the whole wavefront downward, and that's what refraction is. Gradient refraction.
Awesome. You have done your math.
Okay, so Jesse, are you free now? Now that Tommy answered my question, can you confirm for me, do you use spherical geometry for the globe?
So you're asking me that in the chat. Let me just take that first. The difference is so small that to every day-in-day basis, it makes no difference.
Are you sure? Because I'm reading that they don't use spherical geometry for the globe. They have to use a different type of
Depends
formulas.
on what you're doing.
Yeah, so Jesse, would you agree that you shouldn't use spherical geometry on the globe because of the significant errors that can appear?
Well, it depends on what you're doing. For example, when you're calculating, let's say, the distance between 2 points, you can use the Haversine formula. Now, the Haversine formula assumes a perfect sphere, and it is extremely accurate on a perfect sphere. It is reasonably accurate on Earth. However, when you need more accuracy than that, you don't use Haversine, you use a much more complex formula, which takes into account the oblateness of Earth, and then that gives you very, very accurate results.
Is that what you're doing?
What's that?
Is that what you do when you take your measurements for reciprocal angles?
Well, a reciprocal angle is just a reciprocal angle. I mean, that really is not a meaningful question.
On that scale, it doesn't matter.
Yeah.
Go ahead, Tommy, sorry.
On that scale, it doesn't matter. You need to think bigger.
Oh, so the answer is yes, though, right?
Why would you need to think bigger, Tommy? Explain.
Because the oblateness of the Earth is so small that just for a couple of kilometers of measuring, it really doesn't matter.
So why wouldn't it matter for reciprocal zenith in particular?
One more time, because you're falling out there.
Why wouldn't it matter in particular for reciprocal zenith?
I said it didn't. It's too small. What distance did you have, Jesse, on you and your brother? What distance was that again?
7.2 miles. And so, let's say using the Haversine, it calculated as 7.2 miles, but using the correct full oblate globe formula, it calculated as 7.200000001 miles.
Yeah.
Does it really matter which formula I use in that case?
Even flying a plane from Australia to South Africa, you don't do the other one because it's close enough with the Haversine formula.
Okay, thank you. And do you include the radius in these formulas?
You calculate
the radius. The radius.
Oh wait. So the radius is assumed during these formulas?
It's measured.
Okay. Well, it would have to be assumed to be measured because you'd have to measure it to
as
something.
Long as Jesse measures
because I heard Jesse say yes, and then I heard Tommy say no. So who's right?
As long as Jesse measure it, you don't need to take it into account. You just measure it.
When did they measure the radius?
I don't know if Tommy knows about. I don't know. Maybe you do.
If you have a table in your living room, you don't need to assume the length of it to measure it.
No. When did they measure the radius? It's assumed, not measured.
Jesse just told it did with his brother.
So they measured the radius, so they went dig deep.
Wow.
Underneath.
I don't think they measured the radius
Eden,
with that.
I need to answer him. If you have a football, do you need to cut it in half to see the radius of it? Are you serious?
Maybe you haven't ever measured the radius. When have you measured the radius?
Do you need to cut a football in half to measure the radius of it?
You can measure the whole football, can you?
Yeah.
Okay, you can't do that with the Earth, can you?
Why?
Who's done it?
Jesse did with his brother. Just measure the angles.
You measure the whole Earth? Jesse, did you measure the whole Earth?
You don't need to measure the whole Earth. You just need to measure the radius.
Jesse, did you measure the whole Earth?
Wow.
I've measured a bunch of different locations of Earth's surface and found it to be curving in all of them.
That's not my question. Did you measure the whole Earth?
No.
Oh, you mean do I have a tape measure that goes all the way around? No, I don't. But I did see a video about it.
So, Elbow.
So he hasn't measured the whole Earth, Grant. That's something you just said that's completely
up and down, right?
Elbow, I need to ask Elbow a question. If you have a beach ball, do you need to measure the whole thing to find its radius?
Yeah, you could definitely see the beach ball is a ball. You can't tell
No.
with the Earth.
Figure out
because
the radius.
Even you said it. Even you said it that it's very, very minuscule to the minute, right?
If you have a beach ball, do you need to measure the whole thing to figure out?
We already know it's a beach ball.
I asked you a simple question.
Yeah, why do you want to divert to a beach ball? That's a red herring and
No. I asked you a very simple question.
Because you can see a whole beach ball. You can't see the whole Earth, can you?
So we're assuming the beach ball is a sphere.
It's not to figure out it's a sphere. It's to figure out what its radius is.
Are you assuming the beach ball is a sphere, or is it, you know that it is a sphere?
That's what I'm asking you.
So you know that the beach ball is a sphere, correct?
Do you need to measure the whole thing to figure out if
the beach ball is a sphere? Yes or no?
You see it's a sphere. That's not what I'm asking for.
Okay, so can you see the same thing with the Earth, and how did you see this?
I'm not asking for that. I'm asking you.
So you can see the same thing with the Earth, right?
Elbow, let me ask you that question.
Again, you already answered my question, so now I'm asking you. Again, can you see the whole Earth as a sphere?
I asked you a simple question. I would like to have it answered. I asked that first.
Right, you want to divert. You don't want to answer the question.
The answer is no, unless you know the size of it.
Yes, that's right. Yeah.
If Elbow, if you have a beach ball, do you need to measure the whole thing to figure out the radius?
You have to know the size of it. I just answered it. If you don't know the size of the beach ball, how are you going to measure it?
Oh, so you don't do geometry. I see.
Could I not take a straight edge and lay it against the ball and measure the rate of drop over distance and then calculate what radius of curve that matched?
Hold on. So you put a straight edge, right, up against the ball. Okay. Now you know the height and the width. Or you have to know something. You have to measure one part of that hole. And then you have to assume the rest is evenly shaped.
No.
Right? If we're talking about the Earth.
Did you learn in school how to measure the radius of an arc? A simple arc. You draw an arc and you measure it and you find the radius of it. Didn't you do that in school?
Yeah, you need to know the size of it. You need the circumference, or you need the height. You need something.
You're
just saying, I have an arc, right? It's this arbitrary arc. I don't know what point the arc travels across the ball on. I don't know if it's at the midpoint, the 3/4 point. I'm just going to assume, and then I'll make a radius based off that assumption.
Is
that what you're telling me?
What do you call it? A compass? That's the thing you drive a circle with? That's a compass, right? Or what do you call it?
That's a compass.
Yeah, thanks. So if you just take some random distance on that compass and draw an arc, of course you can measure the radius of it without using the center point.
You just swung your compass. You already know the radius.
No,
you start with a known radius to
Just
swing the compass. To swing the compass, you create a radius, and then you actually use it. So what are you talking about? You already know the radius.
No, you don't. You just open it.
You just did your example. You know the radius already.
How?
That's how a compass works. You set the radius and you swing it around in a circle. What are you talking about?
You open
That's how a compass works. You set the radius and you.
You open it randomly. Just open it randomly and
that means whatever distance you pull the compass apart, right,
Yeah.
and then you swing it, right. That will be called a radius.
Yes.
So you're actually setting the radius and then drawing a circle based on that radius.
So
that's how a compass works.
How can you calculate the radius of that arc?
Okay, but you already know the whole size of that. You already know the radius, and you already know the size of the circle.
Forget that part. Just forget that part.
All right, then get rid of your experiment and start a new one.
Compass is just a ferromagnetic material. It's nothing more than that.
Just take that radius. Don't you know how you can calculate the radius of that arc?
Well, you give yourself the known radius, and then you build your analogy.
Forget that part. Forget that part.
Radius.
The arc is there.
Okay, I'm with Tommy for a second. So yeah, we have the circle drawn, but how do you know the arc is actually arcing? What if there are other explanations for this quote unquote arc?
Well, if you measure it 1 inch and it's a 1/4 inch dropped, and you measure it 2 inches and it's 1 inch dropped, and so on and so forth, and then you
I'm sharing my screen there.
But then we already know it's a circle, right? But I'm talking about Earth. Like, what if these measurements that you guys are drawing, and you believe you found an arc? How do you know that's actually an arc?
Please have a look at my screen here.
Okay.
I'm sharing my screen.
Yeah, that's what I'm saying. You have to assume the rest continues to be evenly shaped. Yeah, that's exactly what you're doing.
Do you see my screen there? It's the SketchUp model.
I see something on your screen. There's like a flat guy and a formula. Oh, and an arc. The length and height.
That's the formula for calculating the radius of an arc. You just draw an arc.
Thank you. Okay.
Around there. And you measure the height of it. And you do this. And you figure out the radius of it. So any arc, you can measure if you have the distance of it or if you have the angles of it. It doesn't matter. You can figure out the radius of an arc. That's not
okay.
Really
Perfect.
that hard.
So, but Tommy, let's just say we don't know. Let's go back 500 years. No one's been far enough away, right? And we try to make measurements, and we think we see an arc. How do you know there's not another explanation?
Because as Jesse said, he just measured the arc. He did the reciprocal sinus angles. That's an arc.
Well, reciprocal sinus angles, you wouldn't know the difference between, like, if it's actually refraction causing the phenomenon on both ends or if it's curvature.
Oh,
so,
holy smokes.
You just have to see the light's bending in that case. Like you said, Yeah, there's better and worse ways to do that, but yeah, just take temperature.
Again, so surveying doesn't work then.
You're right. No.
Surveying has never worked then.
Surveying what?
Surveying doesn't work.
Why not?
That's your words. That's what you're saying.
Why doesn't surveying work? Like when you survey things, you just treat it as flat and stationary, right? When you're doing your surveying.
You're using angles through the air. That's what Taylor is saying.
What?
Angles through the air.
Angles through the air. What does that mean?
That's what they're measuring.
But Taylor actually owns and has used her theodolite, so.
Wow. It still doesn't know.
Like the holy grail. That's crazy. So
Jesse
anyway,
measured,
I didn't understand what you meant.
Jesse measured the arc. He measured 2 angles and an arc, and from there he calculated the radius of the Earth. It really isn't that hard.
Yeah, and like in science, you measure something, but that doesn't mean like you draw an immediate conclusion on what's causing it. We know there's an effect, right? There's something that appears to drop over distance for the most part, depending on, obviously there's weather conditions. I think Jesse's even measured somewhere it looks concave or whatever, but things can deviate from normal, but you don't want to assume, hey, it appears this way, so it must be this conclusion, because in the same way, like, if they're aware of light, especially through the atmosphere, like being distorted,
so measuring, surveying
okay, well, let's think of everything this could be and try to rule out each variable in order to make a conclusion. you don't want to jump to conclusions without ruling out all variables that could cause, the same effect. Essentially, that's just typical, just science. Like,
there's a bridge in southern France. There's a bridge in southern France, the world's largest bridge, which they measured across. I guess they hit in the middle there. I guess surveying works.
Wait, you said there's a bridge in France, and what happened? You said on their surveying.
Yeah, the bridge. They built the bridge. It works.
Curved, is that what you're saying?
It's in southern France. It's a really big bridge over a big hill. Over a big.
As if the Earth was curved. Is that what you're saying?
Over a big, what do you call it, a chasm or something? Yeah, the surveying works.
Oh wait,
so
do you have the survey plans? Like, I'd love to see them for real.
I'm just saying that surveying works.
No, I agree. Surveying works. Like,
yeah.
I'm not.
So Jesse measured the curvature of the Earth.
Like,
using surveying.
You're kind of like jumping between points now. I'm not sure what you're.
Yeah, surveying works.
I think it's a language barrier. I honestly think it's a language barrier going on here.
Taylor, you raised a great point, though.
I agree. Surveying works.
Yeah,
I agree
so
with
Jesse
that.
measured the curve of the Earth.
So Jesse measured the curve of the Earth. Okay, so surveying works. You agree that we can take angles, right?
Yeah, that's
all
what
right.
it is.
Those angles can deviate, right, from like completely straight or 9 degrees. All right, so now we say the next question would be, what's everything that can cause this angle to deviate? Either what I'm looking at is deviating, or if there is some optical phenomena that can make things appear to deviate that aren't, that's also possible. And we need to rule them out. You know what I mean? So that would be the next step.
Yeah, but again, surveying over distances work.
I agree that surveying of distances work. Like, whenever
Jesse
you
did.
go out on a typical day, I agree that whatever they say, it's actually what they call standard is in between flat and a globe. It's actually, the globe people say that, things are being lifted up due to the atmosphere, which is why it looks flatter than it actually is. Are you familiar with this? The 7/6R standard refraction? You're familiar with that, right?
Yeah, I used that on models.
Okay, so then we agree, like, all right, there's something that's a standard condition that's making it appear to be between what, would be called a flat Earth and, an Earth with our known radius.
Well, I have to disagree with that because as I showed in my models with my own observation, for my observation to fit on a globe, I need to bend the light just a half a degree or something. If I should fit it on a flat Earth, I had to bend it like 4, 5, 60 degrees the wrong way.
So what they do for like so how do we reconcile? Is light bending down like more, or is it bending up just a little bit? So is it bending down more and it's actually on a flat Earth, but we have light? Well, I say bending down. It's actually bending up. Do we have light making things appear? Like the atmosphere making things appear shorter, much shorter, or a little bit taller? And actually, they're not that much different. We're talking like 8 inches per mile squared, so it's not that much different. But so we're going to figure out like which one it is, right? So it could be one or the other. And in that case, to determine whether it's one or the other, because it's in between both right now, we know something's happening on either model. So you go measure the atmospheric conditions and see which way the light would be bending. You know what I mean? That's what I would recommend.
If the refraction needs to work on a flat Earth, it needs to bend the wrong way than what is known about refraction.
Again, I disagree that it would be bending the wrong way. I think it would be, I personally, in my opinion, think it's going to be bending the wrong way to produce a globe Earth, because they really do neglect the temperature gradient pretty much altogether and just focus on the pressure gradient, because if we were to just go off the temperature, light's bending in the right way for the flat Earth. If we were to just neglect the temperature gradient, go on the pressure gradient, then light's bending the right way for the globe Earth. But
Jesse, you know more about refraction than I do, and I have a pee break.
In the pressure.
Could I say something?
Yeah,
go ahead.
Pee break.
I actually, you remember, Taylor, that link I gave you to that website that you can put in the barometric pressure, the humidity, the wavelength, and the carbon dioxide content, and it calculates the speed of light.
Yeah.
In there, I used that, and I tried a bunch of different combinations to see if I could find any combination where it would cause light to curve upwards while still having the less dense air on top of the more dense air. And I could not find any combination that would allow what you're claiming, because as soon as there was enough moisture, as soon as there was enough density to make the light curve upward, it was already top heavy, which would have made it unstable and would have caused the heavy air to fall.
So yeah, so we need so it would have made the heavy air fall, is what you're saying, right? So
right.
what calculations are you doing to assume that?
I was using the densities. It's been a while. I don't remember, but exactly the details. But it's something that anybody could do, and that's why I'm describing the process. Anybody
Like,
could do
how
it.
do we know what density would eventually fall? You know what I mean? Because we're all near the surface. The air is kind of floating around. I mean, the pressure's not too much higher to where it's just going to fall over. Like, and I know it's a little bit different, but essentially, it's not like toppling down like the air, or else we'd be crushed by the atmosphere. You know what I mean? So I was wondering which calculation, you did to come to that conclusion. But yeah, I'm open to learn anything. Just let me know.
If light needs to bend the way you think it is, we have really unstable conditions. This wouldn't happen very often.
No, we have stable conditions.
Yeah, but then again, light would bend the right way.
No. Yeah. Why do you assume that? I'm just wondering. Like, I want to hear you substantiate that. How do you know?
Because
what are they assuming when you say that's how refraction works? What conditions are they assuming?
This is something that's been done for centuries. This is known.
So what? That's not an answer.
Wow.
Like, I'm open to learning, but when you make these verbatim claims,
you are totally open to denial.
Verbatim things like that. I personally do, because that you're gonna have to prove it if you say something like that.
Okay, so let me ask you the same I asked someone else earlier. What convinced you that Earth is flat?
I never said Earth's flat.
Oh, you do?
No, I said we have to account for all variables to determine one between the other.
I believe the Earth is not a globe and flat, Tommy, myself.
So what?
Also, Tommy,
I never said Earth's flat. I said when we come to any conclusion, we're going to have to account for all the variables.
Yeah, after you've done that, what's left? What?
Known and unknown variables.
What do you mean, what's left?
What shape is it?
Well, that's something that we need to do more measurements on, right? Accounting for all variables.
How would we do that?
Well, you'd go out there, you do. There's different ways. I mean, you can force the line. You can do whatever Jesse's doing with the buoyancy and the strings. You can do theodolite measurements, accounting for the atmosphere. Like, there's a lot of different things you could do.
Except from force lines through the water, as I said, something we can do with the feet on the ground.
Okay, well, look, if you have any good ideas, hit me up.
No, I want to hear yours. I'm really excited to hear yours.
I just gave one that I've been trying to do. Accounting for the atmosphere.
How?
Like, zenith angles, accounting for that, trying to calculate this crazy refraction,
So you don't think Jesse did that?
The actual stuff in.
How should we do that without atmosphere?
Well, I was asking a couple people like Jesse if they could help me with the humidity, because that one's like a whole another ballpark. But apparently it's not that affected. But I still want to see,
if I'm not mistaken, Jesse, humidity would make the refraction less, wouldn't it?
Water has a slightly lower density, or water vapor has a slightly lower density as well as index of refraction than air.
Yeah.
But it makes it lighter. So even if you reduce the low level dense or up index of refraction by having high humidity, you still cause that water, that moist air to rise because it's lighter, it's less dense. So it's not a stable condition that can exist 24 hours a day, 7 days a week, 365 days a year from one mountain peak to another. Yeah. It might exist during brief moments close to surface of water, but it cannot exist consistently at high elevations.
Not brief, but what if it's continuously it seems like it's a continuous movement, kind of like the convection from the Earth, like constantly moving upward, and then mixing or whatever. You know what I mean?
That reduces drastically the higher elevation you get because there's no strong surface to continue heating the air, if that makes sense.
Yeah, I want to look at some data like that. If I could get my drone controller back, like the Pueblos stole my drone controller, and so I have no drone controller.
Oh, so what should you use a drone for?
To put like a nice thermometer and stuff on there to go take some atmospheric readings.
Okay, and how would that figure out the shape of the Earth?
You haven't learned anything so far?
So what she did, or is working on, was putting 2 temperature, humidity, pressure sensors suspended below her drone at different elevations, and then flying it along the line of sight to measure the gradient along the line of sight. So that's what she's talking about, and I think that's a very good idea, assuming that the offset difference between the two are correctly accounted for.
So you get a lapse rate along the side. Yeah, that's great.
And I think a good way to account for the difference between the two is probably fly them over and then have someone flip it so that the one that was on the bottom is now on the top, and then fly it back and do that a few times. And that way you get...
We did it 3 times, but we flipped them and recorded it, and from what I remember, it was the same, like change in temperature.
Yeah.
But I'll have to pull my video to see exactly which is which. I do have some notes like, oh, this screenshot was taken at this time, and here's like where we're at, what we're doing. But in terms of like the times where we're flipping them and stuff, like I would probably have to reference the video because I only have notes on a few of the screenshots.
Then again, if you're doing an observation over water at a distance, if the Earth is flat, you really don't have that much of a lapse rate because you're looking through the same density all the way. So it really doesn't matter if the Earth is flat.
What do you mean the same density? I mean, it's going to be a gradient vertically.
Yeah, but if you're looking straight towards something on the other end, you're looking to the same level.
That's not how it works.
If you are, let's say, 50 meters above the water and looking at something at 50 meters on the other side, you're in the same density gradient.
It's going to be like, you know how we talked about like the hot air rising? It's going to be like happening through your line of sight.
Still, it's the same density level.
That's just not how. Then you never see anything move,
That's because when we have...
It's really not going to move, throughout the day, but paper shows that's not true.
We have the globe, so the density layer is curved with the Earth. That's when it makes a difference. Because I'm looking straight out towards the top of those turbines, and those are totally different.
Do you want to handle that for me?
What do you say?
What's that?
Do you want to respond to his point? My mom just came up to me 1 second.
Oh, ask the question again. What did you ask her, Tommy?
No, I just told her that in my observations earlier when on the turbines, where is shot over a globe where we had a gradient curving, that will make a difference. Not if you are on a flat Earth looking through the same layer.
I'm not sure I'm following.
You didn't. I think you didn't see it earlier. I was showing my observations. I was 21 meters above the sea level and watching some wind turbines 325 meters above sea level. Those are below my eye level. So 68 kilometers away. And
but what does curving have to do with it specifically?
Because then the density layer is curving also. The refracted layers is curving with the Earth.
What difference specifically would that make?
If you're on the flat Earth, you're looking mostly through the same density area. If you're looking just straight out, there would be no difference to the. If you're looking straight out, it will be no difference to the density.
Well, there's no layers. The
gradient.
The layers.
Gradient. Gradient. Yeah.
Right, but no. Even if you were looking exactly level with the gradient line, the equal density gradient line, the light would still curve regardless of flat, globe, or concave, because the wavelength of light is not zero, and it actually occupies a larger space than zero, so it actually curves. And this is evidenced in the fish tank demonstrations where the laser light
I've seen those.
Starts from below, pointing up, curves over, reaches at some point, it passes the absolutely perfectly level line, and it keeps on curving.
I've seen those, yeah. I don't remember if have you seen Craig, Fat to Flat Earth? He had a debate with someone who saw that laser, and that's laser broken.
Well, I've curved light in a fish tank using, of course, salt water and fresh water as a gradient, but also hot and cold fresh water. I put a bunch of cold water in, and I put a plastic sack, and I poured hot water on top, and then I slipped out the plastic sack, and I had a really, really nice hot cold gradient with no salt or sugar. And then I did it with air in a fish tank by putting in rock salt and ice in the bottom, just for a cold bottom layer, and then a heated metal top on top, and I was actually able to create a curve that caused looming refraction inside the fish tank. So we do know that light.
Are you serious? You've been having this whole thing the whole time and you haven't told me?
What's that?
I didn't know you had this whole heating plate. What the heck?
Well, it was aluminum foil that I suspended in the top, and I painted it black, and then I had heat lamps shining on it. Didn't I send you that video? I shall.
No. Did you do it both ways?
Do you have a channel, Jesse?
Do I have what?
A channel.
Did you do it both ways, like the heating lamp on the top and on the bottom?
I only did it cold on the bottom and hot on the top.
Wow.
I did try cold on the bottom and hot on top with water, but I tried cold on top and hot on the bottom with water, but as soon as the water was chilled, it just sunk like a rock to the bottom.
Strange how that works. Do I have a channel, Jesse? YouTube channel? It is.
I'll take you.
Tommy, I really appreciate your time. I usually have to ask this, and I don't want to derail because I am going to go with some friends. Just a quick note. Jesse believes in a creator and God. Do you?
Nope.
Okay, thank you.
I guess we can agree on something and disagree on others. That's perfectly fine.
Yeah, interestingly enough, agnostic globers are a minority in the world, I suppose.
And
where did you
probably
take me, Jesse?
And 99% of statistics are made up on the spot.
Well, I think what society is 10% agnostic atheist, right? So
I don't think it matters because the Earth is what it is, no matter what you are believing in.
Hopefully we can, if you're open for a discussion, we can cover that another time.
Beliefs doesn't matter, and reality doesn't care about beliefs.
That's true.
Jesse, you said, did you tag me somewhere? Or?
I tagged you.
Where?
In the live stream, one text.
There. Oh, I have to scroll a lot.
Dude, if it's really that low,
are you from Jesse? Hey,
if it's only like 5 or 6% of atheist agnostic, then why do people make the argument like, oh, they're doing the flat Earth to hide God? If it's only like 5% of people that are allegedly hidden from the claim of God or whatever, why would people say that they did the whole flat Earth just for that?
The Earth is what it is, no matter what. I've been subscribing to it for a long time.
That's not what I'm.
I don't care.
It's a side topic, and I know we're not shifting to the whole thing. I'm just saying in general, when people make that argument.
What argument?
I think because it undermines the holy books, the Quran and the Holy Bible.
I don't care.
Yeah, but if they're only popping 5% of people from that idea, then they're not doing much. Like they wouldn't make the whole globe lie just to try to hide it from 5% of the people, would they?
Why do you think they're making the globe lie?
I think you cut out a little. I didn't hear what you said. I'm not trying to shift to that whole topic. I'm just. Well, that's the bigger question. Yeah, why are they lying to us about the globe? I'm just saying people that make the argument like, oh, they're doing it to hide God. I'm saying if it's only like 5 or 6% of atheist agnostic, then it doesn't seem like that's enough of a motivation.
I think if you go out there and do stuff, God doesn't matter what it is.
No, I hear you, dude.
I think there's more. I don't know. There's different stats. People classify stuff differently.
Yeah. No, I hear you, Tommy. I'm just sort of like looping on a second.
But there was nobody looking over my shoulder when I was out there. No, not the government, not anyone.
I got you. It's fine. I'm just sort of saying it's a side thing. There are people who say that they're hiding the flat earth and telling us it's a globe to hide God. And all I'm saying is that if it's only like 5-6% of people that are atheist agnostic, that's just not a very big number. It's not like it's 95%. Yeah. It's only 5. That's all I'm saying. I'm just sort of like questioning when people say that argument, I guess. I'm not even saying I don't disagree with it, because I do think they're trying to hide spirituality by the globe thing. They're trying to make it this isolated, materialistic. I bet it's more than 5%, though. That sounds low to me. But then why would that be off? Like I wouldn't doubt it's more like 30 people that are
5
atheists.
billion of the 8
They want to
billion.
be your God. They want to be your God.
Anywho, the Earth is out there. It's just measuring it. It's just figuring out for yourself. That's it. So yeah, but I agree with you. Yeah.
Keep learning, bro. Keep learning.
You're falling out there, Taylor. You're cutting out.
No, I'm just telling you to keep learning. Keep learning. Keep accounting for all those variables, as scientists would say.
How should we do that? Please come with something we can do, except that torque the line, because you had to torque. Yeah, it's a bit. Yeah, something else.
Oh, I mean, I don't know. Anybody have ideas? Somebody did the force. What is that thing with the string and the rope and the?
That's what I said. Except that one, because that won't work. You need to tighten it so hard it's gonna snap.
Oh yeah, if like the tension the rope is higher in the middle, whenever you pull it, like it's a globe or something.
You need to have it pretty far, and to string it without any dip, it's gonna be real tight.
May I tell Tommy about my little planned experiment?
Yeah.
Cool. So, I actually am working on such a crazy experiment. I have 6 kilometers of slightly buoyant string. It has a buoyancy of about 1 milligram per foot. And at that distance, my total theoretical, the straight line sagitta should be about 28 inches. By my very rough calculations, if I can tension it to like 75 pounds of force pull, it should sink under the surface about 10 inches in the middle. So that's what that's all about.
Yeah.
I used a catenary calculator.
So 10 inches and 28, so you had 18 inches of margin of error.
But the point being that this is essentially a qualitative test, not a quantitative test. So
yeah.
It really won't give an exact radius, but if buoyant string sinks in the middle when the ends are at the surface, if it sinks when and only when tensioned, then because we know that the shortest distance between 2 points in 3D space is a straight line, then the surface of the water really can't be flat if tensioning it makes buoyant string sink. So that's
remember the non-buoyant string too.
Well,
so if you have, let me just think.
Dude, and the heating thing only in favor of globe. Come on, bro. You can the heating plate the other way.
You're really bad now, Tyler. Your sound is really bad now.
You can't only do both of them to only be able to verify the globe.
Well, I searched and couldn't find actually neutral buoyant string. So I'm doing the next best thing. So if somebody's got ideas on how to practically get neutrally buoyant string, I'm all ears. but I still don't have much money, so it can't be expensive.
If you have that string just floating on the water first, and
you don't want the string. How would it be neutrally buoyant?
You're not coming through, Taylor. Try getting closer.
How would it be neutrally buoyant?
What's that?
How would it be neutrally buoyant?
Same density as water.
Right. You'd have to blend together different fibers, some of which were lighter than water and some of which were heavier than water, to the point where the net buoyancy was the same as water, because there doesn't seem to be a fiber, a kind of string plastic material that's actually the exact density of water.
But like, okay, so then in that case, what would you expect it to do when you set it in water?
Which? Neutrally buoyant string?
Yeah.
If you pushed it, a foot down, and it was truly wetted, it didn't have any little bubbles stuck to it, it would just stay about a foot down, and it might drift really slowly with water currents, but it would neither be rising nor sinking. That's the definition of that's the outworking of neutral buoyancy.
So in that case, is it like, what kind of fiber is buoyant? What kind of fiber is non-buoyant? And
You're not coming through well. I don't know why,
yeah,
but
like, what kind of fiber is? Hold on, okay, is it better now?
Yeah.
Yeah. Oh yeah.
Okay, what kind of fiber is buoyant? What kind of fiber is non-buoyant? And can we find a mix of both?
PE, I guess that's a polyethylene fiber, is buoyant. Nylon and Kevlar are both non-buoyant.
Polyethylene, and then wait, what was the other one?
Nylon and Kevlar are both more dense than water.
Couldn't we just twist two strings together?
Yeah, that's a possibility. I mean, obviously, twisting 6 kilometers of them together would be an enormous job. A jig would have to be built, and so on and so forth. Or if you wanted enough of this stuff that you could get a contract with the string manufacturer, then they could blend them in their factory, I'm sure.
So okay. If you take that string first, just let it float on the water and tighten it so you see how far it is. Make some tape or something and see how long it is between those fastening points. So you have the same stretching or something when you get below water. So if it gets shortening or something because of the stream or anything, just mark the length of it first before you sink it down. I'm just thinking loud here.
I'm not sure what you're asking. It's going to stretch like 1,000 feet while it's being tensioned. It's not about how long it is. It's about whether or not it can be forced to sink in the middle, even though it's buoyant.
That's the tension, yeah. So if you have just on top of the water first, and then tension it, and then have some markings on it to see when you take it below water. So it's not if the string is getting shortened, that would be for the stream or something. I don't know if I am telling it right, but yeah, just figure out the length first, just floating on top, so you see it. I'm subscribed to you, so I'm going to make a video later and just post it to you so you can see it.
Okay.
Just a simple suggestion.
I can reach out to these scientists. These scientists blended polyethylene with nylon, compatibilized with a sodium neutralized carboxylate ionomer. All right, so I'm gonna reach out to this author right here and ask if they still got this fiber.
Cool.
Mm-hmm.
Let's see. What's that fellow in Austria who is also trying to do the string test? Kevin Samuel, I think. He said, I think in one of his videos, that he reached out to different string manufacturers and tried all kinds of different things, and they wouldn't work with him, without, like a, $1 million order or something. I don't remember what it was, but.
Wow.
So he tried. So he ended up trying to twist, and I guess he did twist some different strings together. He shows it in his video, but he wasn't doing 6 kilometers. He was doing some short test run.
Okay.
I'm waiting for Sly Sparken to do his second bug test with the water level. That would be awesome. He had almost a mile, 1.5 kilometers of water tube with all those vertical sticking up, but he had a leak, so it didn't work perfectly, but that would be great if we did that again.
Anybody else got any ideas?
Geo had an excellent idea the other day, and that was using the time that it takes to transmit a radio signal from one continent to the next, and do that from, a lot of different points to form a distance mesh network. Because once we know the distance between a whole bunch of point pairs in forming all these triangles, then we can cut, strips of paper or something to scale lengths and then attach them all together and see whether they lay flat or form whatever.
Yeah, that'd be dope. I have a radio.
Frequency modulation and 2 different frequencies to determine like a multiple of wavelengths, different distance without timing.
What I was thinking, and I don't want to go too deep into this because this will bore everyone but you. But what I was thinking is use AM in the 10-meter band, which I know most hams don't use AM in the 10-meter band, but it is legal if you have certain license levels or above. And then a 3 kilohertz tone would be transmitted for 1 second, and then the phase of that tone would be shifted 180 degrees, and it would be transmitted for another second. This would allow very simple DSP to determine to within a very, very, within probably a few miles worth of distance, the timing that transition happened.
I like it. Yeah.
So like I would key up, my little box would put out this little 2-second tone into my microphone, and I'd have to hold it really close because each foot of sound distance is 186 miles of radio distance. So anyway, but still.
Dan has an extra license.
Oh, cool. Oh, that's right. That's right.
And he's in radio clubs, and he has access to like good radios.
That's true. I could commandeer the club's 4-element 10-meter Yagi it's on a rotor, so we can aim it.
Let's do it.
Definitely.
Also, sending signals like over Antarctica would be really interesting too, like from South Africa over to Australia, anything that's going actually across Antarctica.
We can look up logs. Like, I bet 50 people have done that this week.
Is that even legal?
Publicly. Oh yeah,
Totally.
Well, how do you know
legality?
We're not talking CB here. There's no distance limits on ham radio. You're allowed to transmit all the way around the globe to yourself, and that's perfectly legal.
Yeah. You can transmit to the moon and back.
Allegedly.
So, whoever's idea this was, start making a list of people with radios. You can put me and Bill on the list.
They'd have to be HF radios and some fairly... Well, a 10-meter antenna doesn't have to be that high off the ground.
Jesse, you have any HF radios?
I do. I haven't put up a good HF antenna yet, but I do have HF radios.
How many?
Oh, a couple, maybe? I know one, and I think some others, but I'm not sure. Oh, wait, no, there's 2. There's at least 2.
You're not selling any of them, huh?
Well, I have to look and see if I've got any extras.
Okay.
Extra radios isn't a thing, is it?
Are you serious?
when you live in a single-wide mobile home, it might be a possibility.
Dude, you're the second person that blank blocked me today. Earlier, I was trying to ask, what's his name, to send me his sheet, his charts. What's it called? Sketch thing.
Yeah, sketch models. Yeah.
Yeah, and Rickskis was like, "Nah, you don't have to send it to her."
But Jesse.
And then I'm like, Jesse, got any extra HF radios? And then we got Bill over here like, oh, there's no such thing as an extra radio. Like, what the heck, bro?
Jesse, I figured out the drawing here now. If you see my screen.
Oh, let me look.
My awesome paint drawing.
Oh, lovely. So,
yeah.
What are we looking at?
Just the water, some water. And
okay.
What I'm thinking was, if you have that string, just tighten it up between those two posts first, so you see the distance of it. Because when it's underwater, you won't see. Just mark off the distance on the poles or whatever you're going to use. So when that line is going below water, if that line is shortening for some strange reason, it would be either current or something else. So just you don't. That's what is it? A fault or something. Yeah, something to take into account for. So if that is just floating out on the water first, when you draw it on the water, you can see if it shortens in because of currents or something.
Oh, I'm planning to do it in an inland lake where there's no current.
Cool. So, what did you say the distance was again?
6 kilometers.
Thank you. Yeah.
I really don't know how length comes into it, though, because I did
just to see if there's a difference between one and the other. If something, as I said, it wouldn't be current, but yeah, just to figure out some faults.
You mean like somehow try to hold it above the water?
Just so you can see the that it doesn't get shorter underwater because of currents or something. But yeah, but if there's still water, it won't be.
Oh, good. Okay.
So.
Yeah, because dry in air, it's going to have like 300-foot sagitta, a sag.
Yeah, that's what. Yeah.
So, and if it's wet, of course, it's going to be even more than that. So, I figured my plan is to put it in a vacuum chamber with slightly soapy water to help break surface tension, and run it under a vacuum in the soapy water to try to get out as much air as possible and soak it in there for a week before I do it. So it's wetted, because otherwise, it takes a while to get all the tiny micro bubbles out of the string.
With the soapy, hopefully also the air bubbles won't stick to it underwater. Yeah.
The problem with the string thing in the water is that you change the density of the string when you pull it, right?
No.
No, because I've heard differently from other Globers. We might have to get a Royal Rumble of the Globers on this topic and sort this out.
So from my Googling, and if you've got contrary evidence, by all means present it, because I want to be prepared for as much as possible here. I don't want any surprises I can avoid. But from my Googling, the indication was that plastic molecules or plastic, polymer chains became lighter when stretched, not heavier, because obviously stretching it might increase the dead space between the atoms without letting water in there, so that would increase the buoyancy, not the density. So if stretching it has an effect, it would be to make it float, which would be in favor of flat Earth. So I really don't see that as a problem. But if you've got contrary evidence, shoot it on over.
And what?
So what are we looking
for
each model?
Or what strength did you calculate you needed to stretch it?
I tested the terminal maximum tension to be 90 pounds.
Hold on, Jesse. You're saying it doesn't change density when you stretch it?
It doesn't increase density.
Does it decrease?
It may.
Well, I mean that's something.
But it would not cause a false positive globe result.
Yeah, you're doing the one. You're doing the one that only proves that it's not a flat Earth or is a globe, or which one? Because there's multiple varieties of this that you can do either way. But which way are you doing it?
Right. If the string floats, it could be caused by multiple causes: surface tension, too much buoyancy, or flat Earth. If it pulls under, then it's pretty single cause that the water cannot be flat. Yeah.
As long as the density didn't change and it's not just sag, because that would happen if there was sag, right?
Yeah, obviously, if the molecules of the string somehow got heavier, gained mass when it was stretched, then it could sink when stretched. But from my research,
from sag,
right? But from my research, stretching, if anything, would increase buoyancy, which would cause it to float all the harder instead of sinking under the surface.
Now, are you going to get a batch of this water, like a 5-gallon bucket, put it in your special little fish tank you got, cut a little piece of your rope off, put it in the middle of the fish tank, and just watch? Are you going to do that?
What difference would that make?
That's what I would do to make sure that, like, what's going on. You know what I'm saying?
No, but here's my plan: is to tension it, and then slack it, and then tension it, and then slack it, and then tension it, and slack it, and see if there's a correlation between it sinking when and only when it's tensioned. Obviously, if it just sinks and stays sunk the whole time, whether it's tight or not, then it's no meaningful results. If it floats and stays floated the whole time, then again, no meaningful results. But if by changing my one control variable, the tension, I change it from floating to sinking to floating to sinking to floating to sinking, then that's the strong globe correlation.
Sounds awesome.
Yeah, but wouldn't it be wise to do what I said with the fish tank? Because that's the first thing I would ever do when I do one of these, is to make sure that it's doing the thing that it's supposed to be doing, or you think it's doing, or whatever. You know what I'm saying? You cut a little hunk off, just a couple inches, and you throw it in your fish tank, and you just, measure it. You have a tape measure or something there, have it be a 6 inches above the floor, and then come back in an hour, come back in a day.
The floating itself doesn't make a difference.
Yeah, I did test a sample of the string in a fish tank filled with tap water or well water, and did confirm that it does continue to float even after months of being saturated. And I also tested with twisted it up with it was just like a 12-inch piece.
But was it tap?
Oh, he'll be back. He's back. Go again.
Can you guys hear me?
Yeah.
Yeah, now we can.
Why didn't you use the water you're going to do it in, though?
I didn't want to drive an hour to go get some. Water's water, more or less.
Sacrifice sometimes, you know what I'm saying? 2 hours round trip, bro. It's a small sacrifice. If you want to be one of the top globers, you got to you got to do this stuff.
Well, I have a high enough confidence level that the waters are similar enough that I didn't see the need. And it doesn't really matter in the end, because either I get the strong sink float correlation, or I don't get it, right? It doesn't matter what tests I do at home ahead of time with the sample of that lake water. The $1 million question is, do I get the sink float correlation? So I took like 40 feet of the string and bunched it up, and I vacuum wetted it underwater with a vacuum pump, and then soaked it in water for months. And then I used a little stainless wire to push it underwater, hooked to a milligram scale, and measured the number of milligrams of net buoyancy with the scale after soaking for months. So I'm very confident that it will behave the same way in the lake.
Tommy, can I ask you one more question before you go? Just call me when you're about to head out. I'd love to.
Yeah, I've been thinking about leaving for a while because it's 5 a.m. right now, so I should be leaving. But yeah, I'm still here.
You're amazing. Thank you, bro. I'll ask you when you guys are done. I don't want to derail.
Yeah, come on.
Okay, thank you. It's a really quick one. I know you have a high certainty of the globe. Maybe you've drawn your conclusion, but what if, just indulge me for a moment, if the Earth indeed was not a globe, it was more of a flat with an enclosure, would then you believe in a God?
No. The shape of the Earth has nothing to do with a God. The Earth is right outside the window.
Okay, I appreciate it. Thank you.
Yeah, but if it's a stationary and planar, doesn't that imply there would have to be some kind of a deeper intelligence involved? Whereas the globe, they kind of have the idea of the Big Bang and the chaotic, outer space. But stationary and planar, doesn't it mean it has to be placed here by some intelligence?
Well, no, there would be the Big Bang and the Big Dome that resulted from the Big Bang when the vacuum ether collapsed. I
mean, I think it's hard to even maintain a globe idea without a higher intelligence.
Good one, Jesse.
Yeah, people look around their environment, and if they're inclined to accept that there was an intelligent creator, they attribute it to an intelligent creator. If they're inclined to say that it happened without an intelligent creator, then they come up with a narrative of how that observable reality happened without an intelligent creator. So it really wouldn't make a difference. It would just be, that's the way it is, that's observable reality, and that's the way it is.
Why aren't there any atheists, planar flat earthers, stationary planar earth folks? Why are there none that are atheist?
I'm pretty sure there are.
I don't think so.
I don't care about anyone who is either or, except for just the shape of the Earth, so I couldn't bother less.
Okay, well, if you're on the side of it where you don't think it would matter, it might matter when you get there, is my point, because it matters to others when they get there. There's a lot of people that have been atheist or agnostic, and they come to a stationary planar Earth, and they're no longer atheist and agnostic. Now, there might be one or two out there that might say that or something, but I don't think there really are any that don't think there's some intelligence that placed everything here.
Well, do you have a window next to your Geo? Somebody can look outside. Do you have that? Geo.
Well, go ahead.
Yeah. Geo, do you have a window next to you so you can look outside?
Yeah, lots of windows.
Yeah, cool. Focus on the furthest thing you can see in the distance.
Just well, it's nighttime right now.
Yeah,
it's
okay.
Nighttime.
So if I told you God isn't real, would anything in that distance change up or down? I guess not.
I mean, no.
No? So it really doesn't matter what people believe in.
So just on point to the earlier statement.
Yeah, I go back to this is a whole topic in and of itself. I mean, I of course the physicality of Earth doesn't change onto what your perspective is, atheist, agnostic, or creator. So I don't think anyone's claiming that. I think what's being discussed though is that if one comes to a stationary planar cosmology, the atheist agnostic position seems untenable. And I don't really know anyone who's maintained that position is what I'm saying. Whereas the globe Earth seems to allow for the maintenance of an agnostic or atheist position because we're this tiny little speck in this huge universe. And then the Big Bang theories and evolution and some of these things. So that's more what I'm saying. It doesn't change what the Earth is. It has to do with what positions are held when the cosmology changes. But it is a whole big topic that we could save for another time.
But just as a point of a fact, if we don't invoke my great uncle, the good, the Scotsman, the true Scotsman, I think Flatty and Tim might be of some sort of atheists. So
they're both globe earthers.
Well, but at one point they were flat earthers, right?
Not really. They seem to cling along. They clung along, maybe, but no, I don't think either of them were.
Did they tell you that they never were? Or are you employing my great uncle, the true Scotsman here, the no true Scotsman?
That's not a no true Scotsman fallacy. If someone says they were a Christian for years, but they never read the Bible nor justified their faith, would they really be a Christian? So I guess not a no true Scotsman fallacy.
Well, but as far as I could tell, they were Ned and Tim were flat earthers. They actually believed it. I had many conversations with them, even private conversations, and I genuinely think they were actually believed it. And unless they told somebody that they were just spoofing or whatever, then it's really by what grounds are you saying that you don't think they were ever actually flat earthers?
Oh, I don't say that. I'm just saying it's not a no true Scotsman fallacy. Because you could just say, because they could just say that they were just as much of a flat earther as you were, right? I could say you're a flat earther, and I have no reason to believe that you're not, because you spend a lot of time talking about the flat earth, right? So what's like you're creating arbitrary grounds to say if someone is or isn't a flat earther, but if someone's a fence sitter, that doesn't mean that they're a flat earther. If someone believes that the earth could be flat, doesn't mean they're a flat earther. Someone believes that the earth isn't a globe, it doesn't mean they're a flat earther. So you have the arbitrary subjective grounds, and you're saying that, like saying they were never flat earthers is a no true Scotsman fallacy. It's not. So there's no but. Do you know what the no true Scotsman fallacy is?
Certainly.
Okay, can you just explain it to us?
Are you saying that my conversation with Gio is officially over by edict?
No, I'm just saying you're trying to reduce what he was saying to a no true Scotsman fallacy, and I'm trying to make sure that you're not saying what he's saying is fallacious. He's not being fallacious.
Did I hear you say that just because somebody believes flat Earth or believes the Earth is flat, that doesn't make them a flat earther? And if so, what is a flat earther if it's not someone who believes that the Earth is flat?
Okay, that's a diversion, but all right.
No, Galatrax, if you want to hash that out further. I mean, I guess what I would just say, first of all, those two people aren't here. So I don't really want to talk about them when they're not here. I don't think that's necessarily fair. Although you did invoke them. I can't say what other people think fully, obviously, but I have generally known those two individuals and the kind of processes. I would say that I actually am an excellent discerner of worldviews of people, because I've been in this for so many years on a daily basis. Back on the 24/7 server, we used to joke, someone would come in and say, I'm a flat earther. And I'll say, oh, I'll see if you are. Let's ask some questions, So that is, you could also say that's my subjective, opinion and viewpoint. So, I mean, I can't claim that I can divine what other people's positions are, and those individuals aren't here. So but it is a thing though, that people could come into a community and there's a lot of whirlwind and they realize globe earthers get insulted a lot more and flat earthers don't, especially on that 24/7 server back in the day. You came in there as a glober, you were on the chopping block to be insulted and banned. Whereas if you came in and said, I'm kind of a flat earther, everyone's going to be much nicer because it's a very culty vibe on that server. So you have that factor. I believe those guys were in that server. There's just a lot of factors involved in and I don't really want to analyze those individuals, but what I'm saying is that from being in this for so many years on such a daily basis, dude, I don't really think I can name one person who actually has a worldview that is for sure not a globe and is a stationary and planar Earth that is atheist or agnostic. That's what I would say.
Yes.
So
yeah,
it's virtually no one.
How would it work?
I can name one.
Are there one or two that might?
I can name one.
Yeah,
I want to know how they think the Earth got here. Then
Andrew, isn't that Andrew
Andrew's
guy
not an
that's a
atheist.
teacher? Didn't he say he was atheist?
No, he's not an atheist. No.
Oh,
Well, he's not a
I thought he
Christian.
said he was.
Is he a Muslim?
He's not a Christian, but he's not an atheist.
Oh, so he's a deist then?
He's, I don't know.
Oh,
He has a Bhagavad Gita. He believes in the
agnostic?
creator. I don't know if he's. I think he just believes in the creator, right?
Oh, okay.
Oh, Taylor,
So
could
he's
you check?
agnostic.
Could you check DMs?
Yeah.
I think if you're talking about Andrew on here, I think he's like agnostic to some
I
extent.
was a flat
but he
earther
does
too,
think
and I
there's a
was
creator.
atheist too. I was a flat earther too, and I'm atheist, so or agnostic. So
Oh, atheist and agnostic are different. But like, tell
I'm
me, like,
agnostic. Yeah, sorry. I
do you
believe
know
there's
anybody,
possibly
or
a
have
creator.
you ever been like a flat earther and you say there's no God?
Okay, I guess you. But you said agnostic, so that was why I said I was but atheist, no.
I don't believe in atheists, so in my worldview, I don't believe atheists can exist.
That
Yeah,
makes
just
sense.
like the lack of a belief.
Well, I
Dude,
mean, that's just
atheism,
as, think about it when I say that, right? Why can an atheist say they don't believe in God, but I can't say I don't believe in atheists?
Yeah.
Hey,
No, I do
Gio.
think atheists exist, dude. It's just a thing. I mean, there are people who absolutely don't think there's any higher power, any creator at all. Like, even outside of any particular religious idea of like Abrahamic or other sorts of a God, like there are some. But see, I would say that atheism goes directly with the globe. Like it was born at the same time as the globe. It's like married to it because there were no atheists before the globe. And that could probably be argued and debated as well. But it's like every ancient culture had a higher power, if I just put it that way, of some sort, an intelligence. Because the only way atheism happens is with the globe model. Like when you have this huge outer space and the chaos and gravity formed balls, and it's the only way like that you could think that everything came from nothing to some extent, and that there wouldn't be some intelligence. Because the Earth being stationary and placed here, and the sky being a grand clock in the sky, there's just no way that there isn't something that put it there.
But like, I think Galachak.
But wait, atheists
Go ahead,
don't
You get
Galachak.
sort of like the point though, Gio, right? Because like an atheist, a so-called atheist couldn't disagree with me. Because
isn't that a
if they
straw
say,
man?
what's that?
Go ahead.
Isn't that a straw man? Because atheists don't claim what we came from. They only claim the Big Bang, but they don't claim they know what happened before the Big Bang.
They claim they believe in no God, not God. So they believe that there is no God. So my claim then to them is I don't believe in atheists. And
Yeah, because you could
because
just not believe in something that's there clearly.
Hey,
so like
Gio.
they have no ground to stand on to say my
But if
claim
you
is
lack
wrong.
belief, then why would you have to prove that then?
Gio.
That's not atheist, that's agnostic.
Gio,
It's
just a
not
few
lack
seconds.
of belief.
Gio, I'm gonna pop out now. It's soon to be 5:30 in the morning here, so I'm gonna pop out. But thank you for your time, and you're doing a good job there.
Yeah, thanks, Tommy.
Yeah, this is way this is way
you
better
did-
than 24/7. I just wanted to say that. Yeah, sorry, he's
I
Gio.
don't have that much of attraction in the Discord, but this was a good one.
Yeah, cheers, Tommy. You did a marathon. That was quite a marathon. So yeah, it was
Probably
was,
gonna pop in some other time, but yeah. See you around.
all right. Yep, sounds good. Cheers.
Bye bye. Bye bye.